Hello students, in this segment we will be demonstrating the use of a very useful conditional statement that is called break. So the break is typically used with the loops, so you can use it inside a for loop or a while loop. So the essential purpose of this break is that whenever within the loop you encounter this break, so it's going to get out of that loop without waiting for the expression over here, right? Or in case of while loop for a condition over here. So whenever it encounters a break, so it's going to get out of this loop without further executing that loop. That was the basic purpose of the break. That if you want to get out of the loop without having without reaching the final condition, so you can use the break, right? So let's see how we can use it within our programs. So let's say we write a very simple program and we ask the user for a certain number, and then we are going to use a for loop, and then we are going to tell him the next prime number after date number. So whenever our loop reaches to date number, it is going to exit that based on the break statement. So let's do that. We have an fprintf statement, and that's telling the user that please enter a number, and I am going to tell you the next prime number after that. So we are going to capture the user input in the variable n, and then we are entering into the for loop. So this is the running variable. It is going to start from n in this case, and then we are running it up to infinity. We don't know the ending condition, so one way of specifying that is to run this up to infinity. And then we are checking for that if it is prime or not. So we are using this code, the function is prime, it returns either a 1 or 0, and we are going to pass it this value. And then whenever it encounters that if it is a prime, so then it's going to break from this for loop and not executing it for the rest of the I values. So I will tell the user that the next prime number we evaluated is %d display it. So now what happens is that whenever the user enters some certain value, it is going to tell us the next prime number, and whenever it encounters, whenever this becomes true, so it's going to display that statement and it's going to break, right? So it's not going to run for the entire infinite values. So when we run it, remember that it is going to give us a warning message as well that the looping index is too much, right? So we are truncating it here, right? So please ignore that. And here it is telling us that the next prime number we will wait is 89. So if we run it again and give it a higher value, it is going to tell us it is going to be 101. So in general, we use the break if we want to exit a for loop or a while loop before the final condition is being met. So we need to use the break statement. One final note on this break statement is that if we, for some reason, are using the nested for loops, such as j equals to 1 up to some condition, right? And if we have that break statement within the inner for loop in this case, right? In this case it is located within this inner for loop, right? In this for loop. So now it's going to exit from this for loop, but it's not going to exit from the outer for loop. So this is very important, and you need to keep a track of that. That if we are using nested for loops and we are using break in the inner for loop, so it is going to exit from the inner for loop, but it's not going to exit from the outer for loop. So let's say for j equals to 1, it is exiting. So then for j equals to 2, it will rerun this for loop again, and then it needs the statement to be true again in order to exit it again from. So that's how it works. Hope you're enjoying the course. See you in the next segment. Hello students, welcome again to the new section and to the new segment. So So in this series of segments, we will be looking at the Matlab programming aspect. With the Matlab programming, you can actually write very meaningful pieces of code, and you can actually control the flow within your program. So there are a lot of different statements for this purpose. The first statement that we are going to learn is the if statement. So we will do an example in order to demonstrate the concepts here. So let's do that. So the very first thing and the very basic thing that you need to know is that the if statement needs to be included in your program if you want to check for certain condition. So if certain condition is met, you want to perform certain operation after that. So let's do a quick example. So let's say we have A equals to rank 4, it will generate a 4 plus 4 matrix. And then we also say B equals to rank 4, it will also generate a 4 plus 4 matrix. And then we want to check if is equal. We have learned the is equal function before, and we are saying the size of A, the size of B. So what this function is actually doing, it will return the size of the matrix A, which is 4, 4, and it will also return the size of B, and that is also 4, 4 in this case. So it will check for equality. So it will check that both these answers are the same. If they are the same, then we can integrate these two matrices together. That is, we can say A, comma B, or A colon B, and then we will be able to integrate them together. Remember that for each if statement, there should be a corresponding AND statement. If you do not include it, the Matlab compiler will give you an error message. So if we run this, you may note that we have the corresponding output. So if we change this, and let's say we have a 5 here, and when we run it, so we see that there is no output. That's because this condition was not being met. So what we note here is that if the condition is true over here, that is, if it evaluates to 1, so what happened is that this piece of code inside the if brackets, it is going to be executed. If this condition is false, right, so this piece of code is not going to run. The other option that you may try here is the else statement. So the else statement is always to be included with the if statement. It cannot be used alone. So if we have an else statement, it will let the Matlab compiler know that if this condition is false, I'm going to execute this. If this condition is false, I'm going to execute this part of the code, and I will skip this part of the code. So in this case, you can mention something like this. You can display a message and say two matrices are not of the same size. So when we run it now, it is going to give us a very meaningful message now. So what we noted here again is that else statement needs to be included with the if statement, and it's going to execute only if condition is false. So if we check that again, we make it 4 and run it again, so we may note now that the second part of this code is not going to be executed. Right? So this is not executed. If we uncomment this, we may note that the first part has been executed and the second part has been skipped. In the next lecture, we will be looking at a little bit different variant of the if statement, so stay tuned. Hello students, welcome again to the new segment. In the last segment, we talked about if, else, and statement. So here, what happened was that we were checking only for one condition. So if that condition is true, we will execute something that is present over here, and if that condition is false, we will execute the statements that are over here. But however, in general, we may have more than one condition that we want to check. And we want to check them in series, right? So if this condition, we want to fetch this condition, if that condition is not met, then we want to check for this condition. If that is also not met, we want to check for some other condition, and so on. So if that is the case, then we need to use a variant of this basic if-else structure that is called if, and then else if statements, right? And at the end we will include an else statement. So let's do a quick example on that and help us in order to learn these series of statements. So let's say we take some input from the user, and that input is the student marks in a particular subject. So I will say marks of the student. And then based on these marks, I'm going to assign a grade to the student. So I will say if marks are greater than or equal to 90, then I'm going to assign a grade, and grade will be equals to A plus. So I will define it as a string, and I will say it is A plus. Else, if marks are greater than or equal to 80, and at the same time the marks are less than 90. So in this case I will assign a grade of, let's say, A, or let's say we call it B. So I can just copy paste it a couple of more times. So here I will say 70, and then we will make it 80, and then 70, and then 60, and one more time. And I will call it C, and this one D, and this one is F. So below 60, I want it to be on. So this is going to be the default option. So if the grade is less than 60, you do not need to mention that. And if none of these statements are true, it automatically means that. So the grade will be F in the default case. So when we enter some marks, it is going to be checked against the first condition. So if it is true, it is going to assign a grade of A. Then in that case, it does not need to check for the remaining ones. Similarly, if it is not true, then it is going to check for this one. Similarly, if it is not the case, then this one, and so on. So it's going to check all the conditions, and if none of them are met, it is going to give a default grade of F if none of the above conditions are being met. So let's run this program and see what's the corresponding output. So if we enter 90, so we need to actually display that as well. Right, so let's display that as well. It says the grade is 8. And if we run it again, it enters some other numbers. Let's say 70. So it's going to give it a C grade in this case. Similarly, if we run it again, and we give it a score of 65, it will say an 8. So what happens is that with the simple if-else structure, what happens is that we are only checking for one condition. If you have a series of conditions, and then you have a default condition, right? So if none of the conditions are being met, so then the default condition that is specified by this else is going to be executed. Remember that when you are using this, you need to have this else as a default option. And with the first if, you do not need to include the else if. And at the end, you need to include this ending statement, which will end the corresponding structure. So that's how it works. So the other thing that you may have noticed over here is that this expression, you can make this expression from the relational operations, right, such as this one, which returns the logical value. Or you can use the logical variables. But remember that with the logical variables, when they are being calculated, they should actually return a single value, either 1 or 0. Right? Similarly, this also will return the 1 or 0. So at n, we only want a single value here, that is either 1 or 0, but you can make it complex and concatenate more conditions over here. But actually, the ending result should be either a 1 or a 0. That's the essential requirement of an if or else statements. That is, they only need an expression which relates to either 1 or 0. So hope you're enjoying the course. See you in the next segment. Hello students, welcome again to the new segment. In this segment, we will be looking at the continue statement. So in order to mention the continue statement, you need to use the continue, a reserved word within the Matlab. So in contrast to the break statement, which actually gets you out of a particular loop, so if we mention break over here, it will take you completely out of this for loop. In contrast to that, when you mention the continue statement, it is going to skip that particular iteration of the for loop and will move towards the next iteration. So whatever you write here is your statements. We are going to escape. We need this continue statement, and it will it will pass the control to the next for loop. So instead of getting out of the loop, it will transfer control to the next for loop. Or if you are using the while loop, so it will pass the control to the next iteration of that while loop. So let's demonstrate the working of this continue with a very simple example that we will be working on with. So now, let us suppose that an instructor took a particular exam, and in that exam he knows that there were 10 students in total. But out of these 10 students, some of the students did not appear in that test, and instead of giving them 0, he wants to give them he wants to skip the data of those particular students for some reasons, such as retake exams or some other reason. So let's make a simple program for this purpose, where if the student has not attempted their test, the instructor wants to skip the data of that. We do not want to enter the data for the student. So how we are going to do that? So let's suppose we first ask the instructor that please enter the student's data for the exam number 1. And then we directly go towards the for loop, and then we know that there are 10 students, so there are going to be 10 values in the best case. So now we are asking the instructor again whether students number, and we are taking that from the input I. Student number 1 has appeared in the exam. So he has two options, whether yes or no. If he says yes, we need first to get that in some variable. We need to store that input in some variable, and it needs to be in string form. So now we are ready. So if C1 equals to no, it means he does not have attempted that test, so we do not need to store that value, right? So we will continue. We will ask the instructor again for the next student. And if that is not true, so we are going to execute the rest of the statements, which are going to be in this case printf. Please enter grade for students, and then we are expecting a grade, so let's say input, and then for the input, it needs to be in numeric form. Like this. So now in this case, if we were using some of the conventional if and statements, right? So in that case, these statements are going to be executed. However, with the continue, these statements are going to be skipped, right? And it is going towards the next iteration of this for loop. One final note that you cannot use the I variable over here, since because some of the students they have not attempted the test and they correspond to students. So you want them here. So if you want to do that, you need to use another variable. In this case, I defined as d equals to 1. And then you will use that d in order to get values into this particular array. Right? So, and then you will increment it now. So now you are ready for your program. So let's run this. You can have station over here, and another station. So let's run this program. So now it is saying whether student number 1 has completed the exam. So if we press no, it is not going to ask for his marks. And if we press yes, it is going to ask for the marks now. So we'll read this again. So another marks. No, 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 yes. So now you understand that what's the use of the continue statement. So whenever it encounters the continue statement, it's going to skip all the statement corresponding within that loop, and it's going to move towards the next iteration of the for loop. Similarly, if you use it inside a while loop, it's going to do the same operation. That is, whenever it encounters that statement, it's going to skip that particular iteration, and it is going to move towards the next iteration. So that's how continue works. Hope you're enjoying the course. See you in the next segment. Hello students, welcome again to the new segment. In this segment, we will be looking at a very important statement for control flow within the program, and that is called the for loop. The for loop is basically used to specify iterations. In particular, it allows the code to be executed repeatedly. So since the code that we're writing now contains more than a single statement, so we will include them in script. We have already included the concept of scripts, so whatever you essentially runs here can also be put in here and run together. So if you are executing more than one statement, it's better to always include within your script. So the basic structure for writing a for loop is to mention this reserved word for, and then provide an initial starting point. So I can define a variable and let's say and give it the starting value. So in this case, the starting value is 1, and then we need to put this colon over here, and then another colon, and then provide the ending point where this loop is going to end. And then we need to specify an end statement, which is basically telling the Matlab that this for loop is starting from here and it is ending over here. Within these two colons, you actually need to specify a step size. That is, this for loop is going to execute starting from 1 and ending at 10. But how many times, or actually after executing it for 1, what should be the next value that it's going to execute? So if I ignore it and delete it, so now by default it is going to have a step size of 1, which means it's going to run 10 times. If I want to run it let's say 5 times, so I will need to put a step size of 2, which will mean that it's going to run for 1, and then it will skip 2, and then it is going to run for 3, and then for 5, then for 7, and then for 9. Right? So if you want to look at the corresponding output, we can do that, and we can say use the display function and pass the running variable, which is I in this case. Remember that the variable for which the for loop runs is called a running variable. So when we run it, so it's now going to display 1, 3, 5, 7, and 9. And so if instead we ignore it and we run it again, so we now know that all the 10 values are going to be displayed. So this was the structure of a very, very basic for loop. And as always, with the colon operator, you can have a loop that is in the descending order. And then the step size will be -1 in this case. So now it will display the numbers in reverse order. You look at run it again, and look at the display. So it is 10, 9, 8, 7, 6, and it is in descending order. Similarly, if we put 2 here, so now it's going to do the same in descending order, but with the step size of 2. Similarly, there can be fractions as well. So for instance, if I start from 0 and I end it at 1, and then I give a step size of 0.1. So that it's going to display the values that are in fractions. So let's look at some other variants that are possible in this for loop. So one of the very useful variant here is to mention a matrix, and the matrix may contain some values. So now what happens is that it's now going to run this for loop for these specified values. That is 5 for I equals to 5, then for I equals to 8 it will run, and then for I equals to 9, and then for I equals to 10. So if I do run it again, you can note that it's going to run 4 times based on the values that are registered here. I equals to 5, 8, 9, and 10. So for each value here, it runs with the corresponding I value. So that's another very useful variant, so that can also be used in programming. Please note one thing more, that in conventional programming, the for loop is typically used in connection with accessing the elements of an array or a matrix. Right? But in Matlab, however, you have access to a lot of functions which actually do the corresponding operation without looping. So it does not mean that you don't need loops anymore. You need it for certain other operations and another applications as well. So let's do a very quick example which will help us in order to understand the basic working of a simple for loop. So this program is going to actually take 10 values of the student grades in the form of percentages, and then it will store them in a matrix, array matrix, or a vector array, and then when the loop ends, it is going to display the mean of all those grades to us. So let's do that. So first we need an fprintf statement which will tell the user what we are going to expect. So we enter this text, please enter 10 student grades in the form percentage. And then we start our for loop. And in this case we know that the for loop is going to run 10 times. And then whenever the loop starts, so we need to display to the user that please enter the value for the student number. And now I want to display the running variable I, which is going to be for the first student, it's going to be 1, and then 2, 3, 4, and so on. And after that, I will need to insert a line break so that the two statements are on the separate lines. Please enter the value for student number 1. And then I need to store the grades into some matrix. And this is going to be a vector. And I want whatever the student entered to be stored here. And then I will add this. And then at the end, I want to display another fprintf command, and I want to say that the average grade is E, and then I will display the mean of the grades. So now we are done with this program. Let's run this and see what's the output. So it's asking, please enter 10 student grades in the form of percentages. Please enter the value for student number 1. So I will enter some marks, let's say 98, then 78, 65, 48. So remember, as we enter the values, this is going to be implemented. This is because this is our running variable within this for loop, which is I. Right? So each time we do not need to specify it separately, so it is going to be taken care of automatically because we are using the for loop. And then we need to enter the last few values. So now it's going to display the corresponding average here. So that's how the for loops works. This was a very simple for loop. So in the next lecture we will be looking at nested for loops. So stay tuned. In this segment we will be looking at a more complicated form of for loop that is called nested for loop. By nested for loop, we mean a for loop, and that contains another for loop inside that loop, right? So remember this program we developed last time. We modified this program in a little while, but in order to demonstrate the key concepts, let us open a new script, and here we are going to have a nested for loop. So remember that for a for loop, we need a starting point and then an ending point where this loop is going to end, and then an ending statement. So inside this for loop, I will insert another for loop. So j equals to 1, and then 5, and then we are going to end. And then inside this for loop, I'm going to display I, and inside this for loop, I'm going to display j. So when we run this program, you will note that for each and every I value here, that is for I equals to 1 first, the inner for loop that is corresponding to j, so it's going to run 5 times. Then for the second value of I, that is 2, it is going to run again 5 times. Then for 3, 5 times again, for 4, 5 times again, and for 5, 5 times again. So in total, it will run 5 and 5, that is 25 times. But the precedence is like this, that for each value starting from the lowest, it's going to run till the end. So if we run it, you may know the corresponding output. So let's look at this output from the very beginning. So it's like this. So for I equals to 1, it has j starts from 1, and then j keep on incrementing, j to 2, j to 3, j to 4, j to 5. Now after this, we do not have any value of j, so I will increment it to 2, and now the j is going to run again. 1, 2, 3, 4, 5. Then for I equals to 3, j will run 5 times again, and then for I equals to 4, j 5 times again, and for I equals to 5, j 5 times again. So let's see what's the benefit of this. So sometimes you may need it in your programming logic in order to manipulate different types of information. One such use is in image processing, where the image is a corresponding matrix, and you want to manipulate the matrix in different forms, like you want to apply filters on your images, or you want to do certain other meaningful operations. So let's have a quick example that we developed last time. Remember from the last lecture, we explained the basic working of a for loop. So now we will do the same example in order to demonstrate the nested for loops. So now, instead in this example, we just slightly modify it, and we say that we have now, let's say, 5 students, and we want their semester grades, that is, they took 5 subjects. Each student took 5 subjects, and we want to enter those 5 subjects values into a particular matrix, and then we want to calculate the student averages. Right? So I would say please enter 5 student grades in the current semester. And then I will enter here from I equals to 1 to 5. So we have 5 students now. And then I will say please enter the values or the grades for student number 1. And then inside this I will have a for loop which will run from I equals to 1 to 5. And then I will also do it like this, a printf, and then I will say please enter the grade number. And so I will say percentage here. Please enter the grade number, the grade percentage. Grade percentage in subject 1 for student 1. So I need a couple of variables here. The first variable is going to be j, and the next variable is going to be I. Similarly, I will now need a two-dimensional matrix over here. So I will need to store the ith, jth value over here. So I will say it is now for student I, which is corresponding to this variable, and j value is its corresponding grade in percentage. And then finally, when this loop ends, I am going to store all the grades, and I am interested in displaying the grades for the student, for the 5 students across his different subjects. So I will say new grades, and it is going to populate in these columns. Right? I will say new grades. When I run this program, it is going to ask for, please enter the grade percentage in subject 1 for student 1. So it says, let's say his first grade is 98, the second is 87, his third is 45, his fourth is 65, and then let's say 98. So now it is going to ask for the second student name. So we need to get into that. And now it is going to ask for student 4 data. And now student 5 data. And finally, it has the average grades for student number 1, 2, 3, 4, and 5. Right? So these are the grades. If instead you are interested in displaying more meaningful messages, you can enter another formula over here. And then you can say for I equals to 1 up to 5, and then you want to display the average based on the students, so you can say the average grade for student number I, so you can say is D, and the second value is expected is the grade E, so E of the grade corresponding to all rows but for the first column. So now it is going to display that based on the student. So that's how it works. Hope you are enjoying the course. In this segment we will be looking at the switch statements. So with the switch you can actually choose from different options that you may have in your program. So let us make a very quick example and then demonstrate the key concepts over here. So for instance, the user may enter some value and you capture that value in the variable n, and then you can mention the switch statement. So with the switch statement, the switch needs to be on a certain variable, right, for an expression. And then you can mention the cases that this variable may take, case 1, case 2, case 3, and then the default case, which you mention by otherwise statement. And then you need to have an ending statement. So here you need to mention the different type of values that you may expect from n. So for instance, if it is 1, you may have some statements such as this: the number is a positive 1. Similarly, for case 2, you may enter a 0 and display a similar message: the number is a 0. Similarly, we can have a -1. And if it is not one of these options, I will say I don't. So let's run this this program, and whenever we enter some value, for example 1, the first case is going to be executed. If we press 0, so the second option is going to be executed. So one thing you should note here is that these are constant values over here. So we cannot have logical expressions or things like that that are something or something and something and so on. So we need to have constant values, right? So if you already expect some values out of this switching variable, then you can mention those cases over here, and these becomes different parts or segments of your switch which are going to be executed depending on the choice over here. This choice can be a character or a string as well. So for character or strings, you can mention it over here. And suppose this is a character, so we can say banana. Suppose they represents the different fruits that a person likes. Mango, apple, and so on. And you can display meaningful messages over here. You can say something like your choice is banana. Similarly, you can display similar messages over here, and you can say choice is apple, or you can say your choice is, let's say, some other fruit, apple, right? Here you need to mention Matlab. So when you run this program, is going to ask for your choice, right? And corresponding to that, it will execute the corresponding statement. Similarly, you can add up more logic over here. For example, some other logical computations can be part here. And based on this, you can add some more calculations. For example, it can be representing your salary. And depending on your salary, you want to calculate the tax returns. So you can mention if your salary is 20,000. So I will do this calculation. And if your salary is in this range, I'm going to do it like this. And then by default, some calculations can also be mentioned over here. Alternatively, you can mention a couple of values over here, 20,000 or 40,000. So now it's going to check for two options, whether if your salary is either 20,000 or 40,000, it's going to do certain manipulations over here. So you can mention either one value or more than one value. So if it is a set, then you need to mention it in the form of matrix. So that's different forms and uses of switch statements. Remember, in contrast to the if-else statement, the if and the else-if structure, the basic difference here is that here you can actually mention complex expressions, while here we are expecting constant values. So if you are interested in constant values, you need to use the switch structure. And if you are manipulating certain expressions, then you better use the if-else structure. One final use of this can be that if you have different pieces of code and you want to execute code number the particular segment of code number one based on certain conditions. So if you have an image processing application, you want to calculate, let's say, the background. So you may say background, or you may want to calculate the average grayscale value. You may say grayscale value, or you want to compute the negative of an image. So you can say negative of an image and then insert proper logic within each and every case statement. So that's how the switch statement works. Hope you're enjoying the course. Hello students, welcome again to the new segment. In this segment, we'll be looking at another very important control flow statement and another family of loop that is called a while loop. So in contrast to the for loop, here you know in advance how many times you are going to iterate. In contrast today, the while loop, you do not know in advance how many times the loop is going to execute. So if that is the case, you are going to use the while loop, where we do not know how many times actually the loop is going to be executed. So let's look at the basic syntax first, and then we will be continuing on with the example that we are doing. So in order to create a while loop, you need to use the reserved word while, and then put some condition here, right? And then there will be some statements which you want to be executed inside this while loop. and then you want an ending statement which tells the Matlab that this one loop spans from here to here. That is from line number 2 to line number 7. So let's do the same example that we're working on. Now here in this case, we are asking the user that whether you want to enter a new student grade or not. And then based on the student data, we are going to calculate the grade as well. So let's do that. So first we are going to display a message to the user that please enter the marks in percentage for the student. And after that I want a line break so that it becomes beautifully aligned on the output screen. And then we want to have another afternoon statement. And here I am going to tell please enter the student marks. And when the student marks are being entered, so I want to drag them in grades. And within these grades, I need to have a running variable. So I need to declare that manually. So let's say I start v from 1. Or we can make it I. I is more reasonable. And then we need to mention I over here. And then input is going to be stored here, and then I need to increment I by 1. So next time when the same group runs, I need to store it in a different condition where I do not lose the previous value. So let's now come back to this condition. Here I need to mention certain logical statement over here, which will weights to a logical 1 or a logical 0. If by default I put 1 over here, so this is going to run forever. It is not going to be halted anywhere. Alternatively, if I mention 0 over here, so this while loop is never going to run. So let's put some meaningful condition over here. In order to do that, I will create first a logical variable, and I say c equals to, which is the condition, logical 1. So for the first time, it's going to be 1. Now let's ask the user if he wants another student data to be entered or not. So let's ask him if he wants to enter another student data. And I will give him two options, whether yes or no. So in order to capture the user input, we need to use the input. And then since this input is going to be in string format, I need to say s. And I will capture this input in some variable, which in this case is called c. Please note that in Matlab is case sensitive, so this c is going to be different from this c, which is small and this one is capital. So this one is a logical variable, and this one is holding a character value that is to be input into the system. That's either yes or no. And then I need to check whether how I can set this condition c. So I need to use if statement, and I will say if the small c equals to yes. Since this is a character variable, so I need to encode it in single quotes. So then I will say c equals to 1. In any other case, I will set c equals to 0. So now this loop is going to be is dependent on the user input. That is, if the user input no here, right? So it's not going to run anymore. If he put keeping on this input is yes, so it's going to run. So let's see how it's going to work. Right, so there is some error fprintf, so we missed some f here. So let's run it again. Now it's running. Okay, so it's asking please enter the student marks. So we entered, let's say 98. So it's asking us again now, do you want to enter another student data? So let's say yes. So it will ask for another student data now, 65. It is asking again, so we say yes again. And it is asking again. So if we press N, it is going to execute and execute while loop. Right? So in order to make it more meaningful, you can say you can add more options over here. So let's say instead of yes, Y, if the user enter yes by default, or by mistake if we write the whole yes, so it's going to exit in that case as well. So if you want to add more options, you can always use more options here and say if C equals to this or C equals to yes. And so similarly, you can add more options over here depending on your user. So if you expect your user that he will always enter the correct character, then it's okay. It's okay to use Y if you are expecting that he may make a mistake, right? Or he may use the numeric key tag if instead of Y and N, he may be inputting values like 1 and 0, so you can add more options. So that's how the basic working of the while loop. So one last note that similar to the simple while loop, we can add concatenated while loops. Sorry, not concatenated, but nested while loops. That will mean a while loop within a while loop. And the working will be exactly the same as with the for loop. That is, for each value here in the outer while loop, the inner while loop is going to execute till the end, and then for the next value, it's going to execute it for the next all values of the inner while loop. One important note is the running variable here. So if you are doing some manipulation right here, make sure that it is keep on being updated. Otherwise, you will lose your previous value when this while loop runs again. And the final note is that depending on the condition, if you put your condition over here, it is also going to be very crucial where you put your condition, either at the beginning of your while loop or at the end of your while loop. So it's always going to be very crucial in building your logic. And the final note is that, as we mentioned earlier, if you know the number of iterations in advance, don't use the while loop. If you don't know the number of iterations, so then use the while. So that's it for this segment. See you in the next segment. In this segment, we will be looking at how we can create our custom-built functions. So recall that throughout the course, we have been using a lot of different functions, such as the range, such as the main function, such as the sort function, and different functions. Now we are trying to develop our own custom-built functions which we can use within our programs. So the basic and very simple type of function is a function which do not requires any input and nor requires any output. Rather, it performs a particular task. So let's say we make certain function. So in order to create function, you need to use the reserved word function, and then you need to name the function name. Right? So we will mention how we can actually give inputs and outputs to a function, but for now we are making a very simple function which does not need any input and nor need any output. So now this function will just display a particular message, and it will say, hello, this is the starting function. Now the next important step is how we are going to store this function. So when we press the save button, a dialog box will appear at your screen. Right. And within the dialog box, you actually need to save this function based on the name that it has. So it has a print function name, so I need to mention the same name, the print function. And it should have a default extension of .m. So this is very important that the name of the function that you are going to save it with, it should match this name over here. And when you save it, it is going to be saved by default here in the default directory. And you can find it over here. There it is here, right? So in contrast to the .m files, you will note a little bit different icon for this function. So it represents the function icon. It should be saved with that. And now you can call it from anywhere. For instance, if I call it from the command window, it will do its job. So I can actually call it the same way as I was calling the other functions, the range function from the command window or some other functions. Alternatively, you can create your own script and call it from there as well. So when you run this program, it is going to be asking you to save your program, and then when you run it, it is going to execute that function. So this was a very simple function which does not take any input and any output. In the next few segments, we are going to consider more complex functions, so stay tuned. In this segment, we are going to create a little bit more complex functions. So let's open a new script. And now this function is going to calculate a square. So in order to calculate the square of a particular number, we need to pass certain argument into it. So the argument that I pass to it is a variable a, and it's going to calculate and return a cross a. Right. It will going to be computing a cross a. This return statement means that please return this as an output to the function. We will return back to it soon in the next few lectures, but for now, let's say it is just printing this fprintf, the square of the input provided is %b a comma a. So now it's going to print that. So we need to save it as well. So by default, if you have not saved it previously, it's going to have in the dialog box, it's going to have the same name as date of the function name. Right? So we just need to save it, and then we note that a different icon has appeared, so we do that. And then we need to call this function. You can either call it from the command window or from the script. So let's say we call it from the command window, so we need to type the exact name of the function and then provide it with some input arguments. So if you provide it with 5, it's going to say the square of the input 5, or provided is 25. Please do remember one thing, that we cannot directly run this square function, right? It's going to give us error messages. The only way to access this function is either from the command window or make a separate script and call this function with some useful inputs. The other very useful and very important topic is the visibility of the variables that are being manipulated within this square function. So let's explain that. So now suppose we have, we call this function from this script and we write its name. So let's say we call it with a variable n, and we define n equals to 5. Now when we run this program, it's going to run perfectly fine. But remember two things, that the variable that are being used over here, that is a, it is not going to be visible over here. So if you press it like this, you say a here in this script where it is not defined. So when you run it, it's going to give you an error message, which means this variable a is local to this function. What do we mean by that is that it's not going to be visible outside this function. Okay? One way of, if you want it to appear everywhere, so you need to create a global, right? Global A. So with the global variables that can be resolved. But however, we do not want that. And in an ideal case, we want, as a good programming practice, we want the variables to be local here within this function. In the same manner, this function, this variable n, which is defined outside this function, is not visible inside this function. So if you press n here and then save it, and then call it from here, it's going to give us another error message, right? So that's a very important concept, that the variables that are defined within this particular function, they are only going to be visible in this function. And the variables that are defined here are not present by default here within the definition of this function. So sometimes it creates a lot of problems as a junior programmers, but you should note these key concepts. Hope you are enjoying the course. See you in the next segment. Hello students, welcome again to the new segment. In this segment we will begin more complex functions having multiple inputs and multiple outputs. So let's create that function. So let's name this function as statistics, right? So statistics of data, and it needs, let's say, two input matrices, and based on the input matrices it's going to calculate certain statistics and give you the corresponding output. So for if your function has certain outputs, you need to mention, if it is only one, you don't need to mention it in the square brackets, you just mention it like this. But if it has multiple outputs, you need to mention it within the square brackets. And let's say we want to calculate different statistics, such as the standard deviation, mean of the concatenated matrices. Right? So we will pass two matrices to this function. It's going to concatenate those two functions, those two matrices, and then finally it's going to calculate the standard deviation, variance, and the corresponding min and max values. So I will say standard deviation, variance, minimum, and maximum. So these are going to be the four outputs of this particular function. So the first thing we need to do here is to concatenate this. We will say we are going to concatenate it based on the corresponding rows, so we make sure they have the same columns. And then we will say standard deviation. This is equals to standard deviation of the corresponding matrix D. We need to give it certain other name because the STD is the reserved one, right? So we can check it here. Yes, so it is the standard deviation is the default or reserved word. We cannot use that. So you can say standard diff. Okay, so standard diff. So this is one of our output. In order to set the second output, it's the variance. We can use the var function and D. So we need to change the name here as well. Variance. Similarly, the minimum is going to be the minimum across different columns. Similarly, the maximum is going to be the maximum across different columns. Right. That's how you can build your own custom-built functions having multiple inputs and multiple outputs, and then you can call it either from the command window or create a new script in order to access it. But before that we need to save it, so let's save it. By default, if you are working with a new script, so it's going to make dialog box with the same name having date of that function already. So you just need to press the save button and you will know that now it is being saved. Now in order to call this function, we will create a new script, and here we will mention some random matrices. Size 4, comma 4. Let's say this is n and this is m, right? And then we need to call that function. The function name is statistics of data, and we need to pass two arguments to it, that is n comma m, and it is going to return those four statistics. So if you know the statistics order, any variable over here, A, B, C, and D, or in order to make it meaningful, you can mention meaningful variables name over here. So make sure it is saved before you call it here. When we call it, so it says minimum not assigned to all statistics of data. So it says some of the variables are not being assigned, so let's investigate that. So this error message reflects that the minimum variable has some problems. Let's check that. Yes, we should have the same spelling as that, right? So now it is being resolved. So let's recall it again. So it is giving us those statistics. So if we look at the graph, it is only D statement was without a semicolon, so the semicolon over there as well. So So now it's not going to display anything. Right. So only the script has been run. You can investigate what is in the A, B, and C, right? A, B, C, and D. So they correspond to our different statistics of within this function. So that's how we can define the function with multiple inputs and multiple outputs. Remember again that the variables that are defined over here are not known inside this function. And the variable that we use here are not known over here, right? They are completely independent. So with this, we come to the end of this segment. See you in the next segment. In this segment, we will be demonstrating the use of the return statement that are used frequently inside a function. So for this purpose, we are going to create a simple example. And in this example, we are going to make a summation of all the numbers up to the number that the user has entered, and we will return that. So let's do that. But first, we want to check if the user has entered a 0 or a non-negative value or not. If that is the case, we will display a message that the summation is not possible in this case, and then we will return to the main program. So now what this return statement is performing is that it will return the control to the point from where this function has been called. So if we called it from a command window, it is going to skip all the function and it is going to jump out of this function and give the control to the point from where it was being called. If we call it from a script, so the point from where we called it, the return is going to return the control to that particular point from where it is being called. So let's first complete this function and then do the explaining in a little bit more detail. So for I equals to 1 up to n, what we are doing is that we declare a variable. Let's say we want to declare a variable summations sum, and that variable is going to be the summation of sum plus I, and we initialize it from 0. That's how it's going to work. So let's save this. So it is now being saved, and when we call it from here with a certain input, let's say 8. So when we run this, it is going to return the corresponding value to this one. So let me not mention any input. We can mention that here, and then we would say the returning value A equals to sum. So now it's going to return. In this case, it was 36, right? So, but if we mention certain value that is 0 or less than that, so it's going to display that the summation is not possible. So it's giving us an error message as well that the variable A is not being assigned, which is an output variable. So we, in this case, will say that, in this case, we will say A equals to 0, right, and return the control to the function. So remember, the input-output needs to be defined if you were calling a particular function. So what essentially this return statement did is that it returned the control to the calling function whenever a function encounters that. So irrespective whether you put this inside a for loop or a while loop or a nested while loop, it's going to skip all that and come out completely out of that function from where it is being called. So that's the job of the return statement. Hope you're enjoying the course. In this segment, we will be looking at how you can actually share the results that you have compiled based on your code. So the Matlab provides you with a very good functionality to publish your scripts, right? So we will be looking at that, how we can make that possible. So whenever you write your code, you can make actually section in your code by pressing this percent sign twice. Right? So when you press twice, it will create separate sections, and then you can provide the headings to your sections, such as main program, and then you can also mention something over here that is subpart. So in the main program, whenever you use once this percent sign, so it will be treated as comment, and it is going to appear in the final document that we are going to generate for the sharing purposes. So we can write this piece of program contains the main program, and then we can say this is the subpart of the program for displaying contacts, and we can comment it out. So now we can add some meaningful code here. For instance, we can initialize certain variables, and then in this part we can actually plot that. So now we have two pieces of information and two sections in our code. So the sections actually divides the program into meaningful segments, right? And the other benefit of it is that you can actually run this individual sections separately in order to see if their outputs corresponds to what you were expecting. So for instance, if I am in this section, if I click here and then run this, that is run this section, so it is going to run only this section. Right? And when I click advance, so it will advance to the next section, and then I can run that section as well. Right? So if you are interested in publishing your results for sharing purposes, right? So you need to click this tab, that is the publish, and then when you click this one, it will ask you to save your file. So when you save it, it's going to run all of your code, right, and generate the corresponding output file, which will look something like this. So now you note that these were the individual sections that we created in our program, right? With the ampersand, a couple of ampersand signs. So when we click here, it's going to take you to that particular section, and if you click here, it will take you to that particular section. Moreover, this was the code corresponding to that section, and this was the corresponding result. Right? Remember that we did not put a semicolon over here. If you put a semicolon over here, so now this output is not going to be part of our documentation. Right? So let's have a look again. Similarly, this was the code, and this was the corresponding output of that code that we were expecting for here. If you look at here, there are more additional options for the publishing results. For instance, you can mention your output file format. For example, I want it to be PDF format. Similarly, I can also mention the output folder name. Similarly, there are other options, whether you want the code to be part of your documentation or you don't want it, right? Similarly, some error messages, if you want it to be part of the document or not. So you can set different options over here. If you include images, right? So what is the default extensions of those? You want it to be JPEG, BMP, or whatever. So when you click publish, it is going to publish those results for you. In this case, it is going to generate a PDF file. It will take some time, and now the PDF file is being generated. Since it was unable to fit that over here, so it has been moved to the next page, and so on. So that's how you can share your results with your colleagues. Of course, there is another interesting way of doing the same thing, and that is by using the online scripts, which you can find from here, right? Live scripts. We will do that in the next lecture. Yeah, for now, you can just do some more examples in order to create your own documentation. So stay tuned. Hello students, welcome in to the segment. In this segment, we are going to explain an alternate way for sharing your results, and that is using the live scripts. So in order to access the live scripts, you can click on live script, and then it will open up this new live image view. So here you can type some code, whatever you like. I have already some piece of code, and I just paste it over here. So then you make it run. So you may notice that the corresponding output is going to appear within the same window where we were working. So we do not need a separate window in order to access the output. And similarly, you can enlarge or make it small based upon your need. So wherever you are having certain output, so here in this case, it is going to generate an output, and it is also going to generate an output. So this output corresponds to this. Right? So when you click on a particular line, it is going to highlight the corresponding output to this one. So if you click here, it's going to highlight this, and its corresponding output is this one. Similarly, we can have the output beneath the statements where it is going to appear, right, like this. So in this case, this was the corresponding output based on the statement, so it is going to appear very close to that. Similarly, this plot is going to be plotted after we have set these customizations, so it is appearing over here. Similarly, the other quality of this is that you can add sections. You can add the textual information to each section. So the second section of our program. Similarly, we can add some more text here. This is the first part of our program, and so on. Similarly, you can add equations to your program as well, and you can add images as well. So for instance, here I want to add an image. I can click it over here and then select the property which I have on here. In this case, it's some random image, and you can always resize the image, enlarge it as well. And you can always do some text processing, such as bold, italic, underline, and so on. So I want this to be bold, so I can do that. Similarly, you can insert a hyperlink array, and you can also add equations within your environment. So equations can be either typed based on these kind of options. That is, if you want to have fractions, just click over here and mention any denomination that you want to have. For example, you can check from these available options. So there are a lot of different symbols, relational symbols, arrows, brackets, and so on. And similarly, we have a lot of different magnification here as well. So you can choose from that. Alternatively, if you are going to use that tag, so you can also use the line tag in order to run it. So let me show you that. So when we go in here to the line editor, and we want to get some equations with. So when we press here, we have two options. One is the equation using the Matlab, and the other one is the line tag equations. So in line tag, there are a lot of symbols. For example, if you say delta, it's corresponds to that. So eta, it's corresponds to that. Similarly, you have the set operations. So this will be for union, we have big count. And similarly, for simple union, we have count. For smaller union. Similarly, for intersection, for element, approximation, and so on. So if you are not familiar with that tag at all, I had a Udemy course on that tag where you can find all the corresponding information. So it contains all the information that you need to create documents using that tag. So MATLAB is a very powerful tool and a very professional tool in order to create research papers and presentations and other kind of documentation that you want to create. So it's a professional way of doing that. Let's come back again to our main topic. Some of the other options that you may want to try is to make a heading for this section. So suppose I want to say this is subsection, and I want to make it a heading of this section. So I can say heading. Similarly, if you want to insert some numbered list or bulleted list, you can select one of these two. Similarly, if you want to have some code into this, right, so you can always do that. Similarly, if you want to insert some comments, you can do that. And there are so many other options that you can try. Finally, when you are done with all of your line editing, right, so you may want to share it with your friends. So if you want to share it, there are two options. One is that you do not want your colleagues to edit your script. So in that case, you will generate a PDF. So go to Save As, and then in the Save As option, select this one, and it will run all of your script waiting, and then generate the corresponding PDF. So in this case, this is the corresponding PDF. Alternatively, if you want them to edit your script, so and they may want to do some meaningful manipulation in your script. So what you can do is that you can share the corresponding .mlx file. So you need to just save it as .mlx and share this file with them. So they need to have a Matlab installed on their computers, and they will be able to make addition and contribution to your existing programs. So that was a very useful tool, and I strongly recommend you to use it in order to make presentations or share with your colleagues or for teaching purposes as well. Stay tuned. Hello students, in this segment we will be looking at some more operations on the cell. So remember, we have created a cell in the previous lectures, which was this one, right? So in this segment we will be looking at how we can actually access the individual elements within its cell using the indexing. So one way of doing it is to use the curly braces. So if we use the curly braces, so the curly braces mention a particular index within this cell array, so it will return the contents of that particular cell array. So, but here we have an exception. That is, if it is a simple item, it will return you the value there, right? Whatever we have at that particular location. However, instead, if it is not a simple value, but some other kind of data structure, for instance, if we consider this one, this is not a simple data, it is 5 cross 2 cross 3 matrix, right? So if you mention that, that is the second 2,2 item here. So if you press enter, it will return you all the values. So how we can actually get the individual value within this particular cell? So it is not going to give you individual values, and we are interested in the individual values that are present at that particular cell. So for that purposes, you need to use the smooth brackets after these, right? And if you are interested in a particular item, you can mention the index of that. So for instance, if we say 1, 1, 1, so it is going to give us the first value that is present in this particular cell, which is 0.6022. If we say 1, 2, right? So 1, 2 will be this value, comma 1. So let's do that. 1 comma 2 comma 1, so it is going to give us the second value. And if we are interested in this value, so we need to say second row corresponding to the first column, and it is first data item we're looking at. So we need to say 2 comma 1 comma 1. So in that case, 2 comma 1 comma 1, it is going to give us 0.3868, which is the exact value we need. So the thing to note is that with the curly braces, you can actually get the items, the values that are there at a particular cell. But if the cell is composed of some complex data structure, so you can use these smooth brackets in order to get the individual items extracted out of that particular cell. So let's see again, and here's one more example. So for instance, if I want to retrieve this, which is the textual information, so how we can do that? I need to mention its corresponding index, which in this case is 2 comma 1. So it will give me the value of text. However, if I am interested in these individual items, that is T, E, X, and T, so I can still do that. And I can mention first value, that is T, second value, that is E, and similarly the third value, and so on. So that is for if we are interested in the individual items within that particular cell. So you need to use these brackets. So with the curly braces, you can get the individual items of the cell. However, if you mention and use the convention that we frequently use with the matrices and arrays, so if you use those smooth brackets and mention a particular location, so 1 comma 1, so in this case it will not give you the value that is present on that particular cell, rather it will give you another set. So it will give you a set which contains the information about that particular cell. So if I mentioned 2 comma 2, so it will give me the complete set, and its type is going to be a cell, right, not the contents. If I'm interested in the contents, then I need to mention it with the help of those curly braces. So that's the essential difference between the two. That is, with the smooth braces, with the smooth brackets, we refer to the sets of cells, and with the curly braces, we are interested in the values that are present there at a particular cell. So let's see one more interesting example. If we contain somehow cells that are contained within another cell. So we know that we can define cell with these curly braces. So now this contains more cells. Right? So this is a particular cell array, and this is present within this bigger cell array. So if we look at it again and see the C, so then the C contains, this is a simple cell, this is another simple cell, and so on. However, it says that it is another cell which is contained within this C. And if we look at cell plot, so we may get more intuition about that. So now it contains another cell, right? So it has the same, it has those boxes which contains other boxes as well, so it means it is another cell. So if we have that situation, and if you want to retrieve the contents at that particular cell, so it will give you cell itself, right, not the contents, right, because it contains a cell. So what is the way around to get to those individual items? So you need actually to use a double indexing with those curly braces, and then you can mention the individual values over there. So it will give you the contents. Why? Because for the first one we get the contents that are present at that cell position, which itself is a cell, and then we get another brackets in order to get the individual contents out of that cell. So that's how it works. Alternatively, you can also mention it like that, 1 comma 1, because it contains only one row, 1 comma 2 and 1 comma 3, or you can directly mention it. We know that for the column, for the vectors, you can either mention it directly, or you can mention it explicitly by saying 1 comma 1, or 1 comma 2 or 1 comma 3 or directly simply by 1 2 3. So that was a little bit a tricky part, and you can always think of if it contains further cells and so on. So if there is a tree level of cells, so then you need to index it using three curly braces. So that was it for this section, and in this section we learned how we can actually retrieve the values from a particular cell. So hope you're enjoying the course. See you in next segment. Hello students, welcome again to the new segment. In this segment we will be looking at how to add and delete elements into a cell. So let's say we have a cell, we define it as C equals to, remember when we use the curly braces, we are defining the contents that are going to be part of this cell, right? So let us say we define a simple kind of a cell, that is, it contains 3 columns and 2 rows, right? So there is a 2 cross 3 cell array. So if we want to add some item into this cell, and let's suppose we want to edit it at a particular location. So for instance, we want to edit at 3 comma 3, and we want to add a value of 9 here. So what will happen is that it will first check whether this falls within this range. So it means it is not falling in this range in this case, because we're expecting an item that is going to be inserted here. So since the number of rows here is greater and it is not within this range, so it will add a whole row and the ending value will be 9. Right? So it also appended 2 more empty cell locations within this cell array. And that is because we have already noted that it is of rectangular size. So if you mention something that does not fit into that rectangular size, so it will either 8 columns or rows in order to make it rectangular. So for instance, if I enter 3 comma 4, so now it will add 1 more additional columns. Why? Because the columns currently are 3 and we are expecting another value in the 4th column. So it will now add another column to the existing cell array. So that's quite important, you need to note it down. That the default restriction on the cell is that it has to be of rectangular shape. So if you enter a value with the indexes that falls outside of that rectangular shape, so it will either append more rows or columns depending on the indexes that you mentioned. In order to delete an element, we can still use the indexing, right? So the curly braces. So for instance, I do not want this value. I want it to be empty here. So we can directly mention its index, and I can set it to the empty value by mentioning nothing in the square braces. So it will delete that value, which was 6, right? So we mentioned 3 comma 3, which is 9 in this case, and now we have deleted that 9. If you want to delete this value, this is 2 comma 2, so we can mention that. And remember that we may have some complex value over here. For example, we may have a matrix over here, so we can still delete that. So let's first assign a matrix to the 1 comma 1 location. We say 2 5 and 6 5. So now it's a 2 cross 2 matrix. If you want to look at it, so you can say C 1 comma 1, and it will display the context there. Right? So it is complete. So we can still delete that as we were doing it previously, and now the new result will be that the matrix has been deleted from that particular location. So that's how it works. If you want to delete a whole row simultaneously, so for that purpose you need to use the smooth braces, and then you need to mention the number of rows that you want to delete. So for instance, I want to take rid of the first 2 rows corresponding to all columns. So you want to delete the whole sets. So that's the way that we need to use the smooth braces, because we are interested in deleting those whole sets rather than individual values. And then you need to mention with a suitable logic over here which rows or which columns you want to delete. And then when you press enter, it is going to be deleted. So these the first two rows has now been deleted. We only have the last row. Similarly, you can delete the columns, and you can mention the corresponding to all rows. I want to delete column 2 to 3. So it will now return the first column and the fourth column, and these two columns has now been deleted. So if you want to delete sets of cells, you will use these smooth brackets. And if you want to delete individual values, like if you want to reset them, so you need to use the actual curly braces. But remember, it will just delete the current contents. The cell will still remain over here. Right? So if you want to delete the cell, the corresponding cell as well, suppose you want to delete the sets of cells corresponding to rows or columns, then you need to use the smooth brackets. That's it for this segment. In the next few segments, we'll be looking at how to concatenate values of different cells. So stay tuned. Hello students, welcome again to the new segment. In this segment, we will be looking at how we can actually concatenate or combine different cells together, different cell arrays together. So there are essentially two ways. One is to combine them horizontally, and the other one is to combine them vertically. Right? By vertically we mean row-wise, and by horizontally we mean column-wise. So let's define a few cell arrays. So this is our cell array 1, which contains 1, 2, 3 values, and this is our cell array 2, which contains some strings or characters. And then we have cell array 3, which contains some more values. So now, if we want to concatenate them together, one way of doing this is to just supply the names of those and include it in square brackets. So when we do that, it's going to be concatenated in a single row. And remember, it will be a single row, and all the contents are going to appear here as they were appearing here. So instead, if you enclose it in the curly braces, so now the meaning will change. The meaning is that we are defining a cell whose first element is going to be this one, the second element is this, and the third element is this. So it is not going to be a 1x9 cell array. It is now going to be a cell array of 1x3, and each and every element is itself a cell. So it is 1x3. Each of them is 1x3. Right? So it's a little bit different. So when we include it in the curly braces, it means that we are specifying individual elements of the cell, of the corresponding cell, and these individual elements can be single items, or they can be itself a cells. Or if when we include it in square brackets, then it means we are supplying its individual values, and please consider them while we are defining a particular cell. Similarly, if we want to concatenate the cells row-wise, so then we need to insert a semicolon between the different values, and then it will append them row-wise. Similarly, for column-wise, we can delete that, and then it will append them in a single row, and it will be dated as columns. Right? So these are the three values corresponding to C2, and they have been appended as columns, and these are the three values corresponding to C3. Similarly, if we add curly braces over here, so then it will means it will have different meaning, right? It will return a column vector of cells whose individual items are 1x3 cells themselves. So that's the essential difference between the square brackets and the curly braces. With the curly braces, we are specifying individual elements that are going to be part of the cell, and with the square brackets, we are actually mentioning the values. Right? So these two can be handy. So finally, we'll look at how we can use actually the different elements or the different cell values that are present within a cell So we can extract them basically with different elements and then we pass it to some built-in functions. So for instance, let's have a look. We define, first of all, declare C. Okay, so then we define C as, let's say, we define some values over here. So we say plot data, and then the second cell will contain the data, right? So we want to have some data, random data, and we call it 20,2. And so when we press enter and look at what C contains, so C contains only 2 elements. While if we look at the cell plot, so here we may notice that the C contains 2 cells, and in the first cell we have this data, it is plot data, it is a string array, and then we have in the second cell we have 20 rows and 2 columns, so 20 by 2 matrix over there. Right? So these are the 2 elements. So let's suppose now we want to plot these values. So how we can do that? So we can use the plot function. And with the plot function, we can actually pass this second element, this second element of C. So how we can do that? We can actually mention its contents. So it is a 1, 2. Its location is 1, 2, and we can pass it to this plot function. And then when we press enter, we get the corresponding data. So that's how we can pass the data of a particular cell into a plot function. If for some reason we only want to plot only the first 20 values corresponding to the first column and not the second column, so we can always do that. We can specify that I need all the rows corresponding to one first column and then plot it. So we expect one plot over here. Remember that we have covered it that whenever we mention after the curly braces, if we mention the smooth braces, so we can actually access the individual items that are present at that particular cell location. So that's how we can do that. That is parsing particular cell values to a particular function. Hope you're enjoying the course. See you in the next segment. Hello students, welcome again to the new section and the new segment of the course. In these lectures we are going to look at the cell data structure. So the cell data structure is an essential component of your Matlab learning. And the essential difference between the cell data structure and the other usually used data structures such as the matrices, arrays, is that the cell can contain different types of data. Right? So earlier we have seen that the matrices and the arrays or the other variables, they can contain only one type of data. So the cell can contain different types of data. More formally, cell is a data type with indexed data containers called cells. So each data container is called a cell, and each cell can contain different type of data. The requirement on the cell is that it is rectangular in shape. By that we mean that if we have 3 rows in a cell, so all the 3 rows should contain the same number of columns. Right? And if it has 5 columns, then each and every column should contain the same number of rows. Right? So we can define a cell, for instance, of 4 cross 3 or 3 cross 7, right? So whatever size you want, but it should be rectangular. So that's the few things that you should know about the cell. So now let's straight go to how we can define a cell. So there are essentially 2 ways to do that. One is if you want to directly define the values that are going to be part of the cell. So in that case, you need to mention it using these curly braces. So by these curly braces, you are going to define the individual values that are going to be part of that cell. So if we create it like this, so it will say a 0 cross 0 empty cell array. The other way is to use the reserved word cell and then use these brackets instead of those curly braces, right? And then mention the size of that particular cell. So if we mention 4 cross 6, so it will contain 24 cells. So similarly, we can have three-dimensional cells, and you can say it like this, or any other dimension that you want. So the essential difference between these two definition types is that with this, it is expecting the individual items which are going to be part of the cell, and with this, it only expects the dimensions of the cell. So these two are the ways. So let's do some more examples with the first method. So here we can mention the individual values, and the individual values needs to be separated by this comma, right? So it means now a 1 cross 3 cell. So similarly, we noted earlier that the cell can contain different type of values. So now I am mentioning the second row. This first cell now contains the textual data, and here I can mention the golden function, that is the array, and I am initializing an array, a matrix, a three-dimensional matrix over here, and then finally I can mention my cell. So now it contains different types of data. So when we press enter, you may notice that it has created a 2 cross 3 cell array. The first cell contains only a single element. The second cell also contains a single element, and the third cell also contains a single element. However, this first cell in the second row contains textual data, and now it contains a 5 cross 2 cross 3 matrix, right? And this contains also the string data. So there is also a very important function in order to look deeper and visualize the contents of the cell, and that is called cell plot. So it is very useful in order to look at what are the different cell elements. So in this case, it says that the first cell element is just a single data item. Again, a single data item and a single data item. However, the second row and the first element in there is textual data, and it contains 4 pieces of text. So text, that is the text that is going into these boxes, and then it is creating a 5 cross 2, right? So it is 5 rows, 2 columns, and then there are 3 separate versions of that. So it means 5 cross 2 cross 3. So 5 cross 2 are the array, our matrices, and they have 3 instances of that. And finally, myself, it is also contained here. So it's a useful way in order to look at what are the individual contents of your cell. That is the cell plot. It will give you some intuition behind, or like, what is the cell containing. Okay, so one more important function is the cell function, cell display. So it will display all the contents of the cell, that is cell by cell. So first of all, it will display all the items that are contained in the 1,1 cell, which is this one, and then the 2,1 cell, which is the textual information over here. Then it will display the contents of 1, 2, and then 2, 2, and then 2, 3, and finally the 2, 3 cell, right? So it is going to display it, but the display order is like this, right? So it is column-wise display. So that's it for this lecture. In the next few lectures, we will look at some more operations on the cell. So stay tuned. Hello students, welcome again to the segment. In this segment, we will be looking at how to delete and add rows to a particular table. So let's start working with our table. This is our table, and we want to add another row to this. And so remember that if you want to add a row to a table, you need to have that additional row also in the form of a table. So we need to create another table for this purpose. We need to say table, T2, and we will insert some rows into it. So now T2 is also one row based table. Now if you want to add that, remember that these T2 should also have the same variable names as date of T in order to append that like this. So this will not essentially going to work. Like this was we usually do it in with the matrices, but in order to do it with the tables, T2 must have the same variable names as date of T. So it will give you an error message. All the tables in the bracketed expression must have the same variable names. So how to get around with this? There is an easy way to do that. And you can say T, and you can mention that based on the indexing, T n plus 1, which means the end row, and with the end row 8 1 order corresponding to all columns, and we say that is equal to T2. Right, so now we have noticed that we now have row number 6. Similarly, we can say again, and now we have row number 7, and so on. If you want to delete it, so it's also a simple process. So you need to basically say, if you want to delete only one, so you need to say n minus 1, or you need to say 1 2 and minus 1, and you need to assign it to T. So now T will be equals to T, but one row is subtracted from that. So if you press it, one row is subtracted. If you press it again, another row is going to be subtracted. So that's based on the indexing and the comma operator, based on which you can add or delete rows simply. The other option that you may try for deleting a particular row is to directly to directly mention the name of that row. The name of this row, for instance, is this one, right? So you need to mention the name of that particular row, and say corresponding to all columns, please delete that. So now the table has been updated and it does not contain this particular row. So that's another option that you may try. Some other interesting option that you may try for deleting particular rows is the use of the logical variables. Remember, the logical variables contains only ones and zeros. So ones for the case when the expression in the logical expression is true, and 0 in the cases when the logical expression is false. So let's examine the data that we had previously. So we had this data. So it contains 5 variables. So let's see how we can do that. So let's say we are interested in x dot var 1, which is our variable 1. And so we want to say, okay, if for those values which is greater than 5, you assign it to a temporary variable, say temp. And now we may look at that. What is the size of the temp? So the size of the temp is exactly the same as date of the size of this variable. So this variable contains 150 values. So if you look at x, it's 150 values. So this temp is also of the size of the same size, but it will contain only ones and zeros. So in all the cases where this condition is true, it will contain 1, and in all other cases, it will contain a false. So we can actually use these ones and zeros in order to select our data. So we may say x temp and corresponding to all columns, please delete them. So this essentially means that analyze all the values in the temp, and look at if its value is 1 or 0. So if its value is 1, correspondingly that row will be selected, and if its value is 0, so that corresponding row will not be selected. Right? So if we press enter, right, and make an examination of x, so x now has only 32 values, while initially it was having 150 values. So that's, and you can always mention more complex logical expression over here. And so you can add more expressions like x dot var 2 is less than 3, and so on. So this is a logical OR operator, which means if any of these conditions is true, then return a 1 over here. Similarly, you can mention an AND operator here, which means when both of these conditions are met at the same time, then this is going to hold a value of 1. In either case, it will hold a value of 0. And then you can use this variable to select the rows. Right, so that's how logical operations can work and can be used in order to select certain rows within the table. So that's how we can add and delete rows from a table. Essentially, there are so many other ways. It's a German rule in Matlab. For every task, there are so many different ways to do that. That depends on how, on what your problem at hand is. So, hope you're enjoying the course. See you in the next segment. Hello, students. Welcome again to the new segment. In the last segment, we have looked at some basic operations of the table. So we built essentially on top of those. Hello students, welcome again to the new segment on the tables. So in the last lecture, we mentioned that the table needs to be created from the already existing variables. If for some reason you do not want that and you want to define the tables yourself, so then you need to mention all the values that are going to be part of the table yourself. So for instance, I want to have 3 values for the first variable, and then I want to have a set of 3 values for the second variable, and then I want another set of 3 values for the third variable. So then when we press enter, there's going to be something wrong, so let's fix that. We need to give it a row, a column vectors. So now we have created the tables. Since we have not mentioned the names of the variables, so that's why the default names are var1, var2, and var3. You can always change that by saying table.properties, and we are trying to access the properties variable names. So you can say, give it the names of the variables. So the first variable I want to say variable 1. For the second one, I want to say variable 2. And similarly for the third one, I want to say variable 3. So now we have updated our variable names here. Some other interesting properties that you can modify for the tables are, number 1 is the variable units that you can mention. So remember, we have created this T table in the last segment, so we can actually add some units to the description, the units for these particular variables over here. So for example, in ages, I may mention that t.properties, and I want in this case the variable units. And I want to mention that for all the variables. So for the first one, I want the ages to be in years, so I say years. And then for the second one, I want to mention it in foots, if I may say something like this. And then for the third one, I may say kgs. When I press enter, it is going to be, oh sorry, we need to say units. So now it's going to be applied. Now you may wonder where it has been applied. So in order to look at some statistics of this table, we may use this summary option. So summary keyword, and then give pass it to the table as a parameter to it. And when we press enter, it's basically giving us some statistics about our tables. Right? So the units that we have mentioned is also appearing here. So what essentially it means is that it is a kind of a metadata. What do we mean by metadata is the data about the data. So it is our original data, and there is some data behind this, which is this, right? The units for the first variable, and it is also giving us the min, median, and max of this particular variable. So it gives us some basic statistics about the different variables that are appearing as part of our table. Similarly, we can add descriptions. So we can add description for the different variables. and we can say variable description. If we don't mention something over here, it means that the Matlab is expecting description of all the variables. But if we mention some value over here, for instance, our first variable is ages underscore years. So if we only mention some description, it will only be applicable for that particular variable. And so we can say this variable contains ages in years. So that's our description. Probably there's something wrong in the spelling of description. We need to say descriptions over here. So that will aid the description for the variable ages underscore years. But again, in order to look at it, it is stored as a metadata. So we now have the description for our ages units and then description. If we want to add description for all the variables at the same time, so we just need to take rid of this additional argument, and we need to enclose it in an array, sorry, in a structure. So we can mention for the second variable is description. For the second variable, we want this represents height, and similarly for the third variable, we can also get some description. This is the weight variable, and then you can press enter. So now that descriptions has been stored as a metadata, and in order to access that, we can always see its summary. So now we have corresponding descriptions as well. So it's quite useful. In the lectures, we will be looking at how to store these tables, and then you will be looking at that this description is quite useful when we save it to a permanent file. So this description will always be saved with the tables as well. The other important thing is that if you want to access individual elements of a table, for example, I want to access only the first variable, that is the year. So we can always use the dot notation, and we can say t.ages underscore year, and it will return the first variable for us. Similarly, if we want to access the second and third, we can mention their names. Make sure we don't make any mistake. Okay, so probably the name is not this, so I misspelled it. Yes, so we have now the corresponding values over here. Similarly, we can do some automation on that. For example, we can say this is equals to t dot phase underscore ages multiplied by 2. So you can think of all the operations that you may use within the Matlab environment, and you can do that. So now our weights have been updated. Right? So that was only one way of accessing different variables. Of course, there are other ways for accessing the different columns and different rows within the table. That we will cover that in the later segments. That's it for now. See you in the next segment. Hi students, welcome again to the new segment. In the previous segment, we have covered how we can actually aid in the rows into the table. So in this segment, we'll be looking at how we can aid in the columns. So remember, we had this table from the previous segment, which contains 32 rows and 5 columns. So if I want to aid in the column group, I need to say x dot, let's say 6th column. And I want to just add random values to it. So remember, this range is a built-in function which will generate 22 random rows containing random values between 0 and 1 and 1. So when I do that and I investigate again x, so you may notice that this appears as a 6th column. So whatever name I mention here, it is going to appear as the default name of the column. So if I say 7, or I can say bar 7. So now it will be added as another column to that table. Similarly, deleting a particular column is quite straightforward, and you just need to mention the corresponding name of the column. Just put into braces in front of it. And now it will delete that from the matrix. Right? So bar 7 has been deleted. So now we can delete the sixth column, and we can say sixth column, the exact name of the element, and we can assign it. So now we have the original matrix, and we have a way to do the same operation. Now we have added a new column. Another way of doing the same operation is that you can say x equals to x, corresponding to all rows and corresponding columns from 1 and minus 1. So it will delete the ending columns from there. One of the ending columns will be deleted. So now you may notice that the ending column is deleted. Similarly, you can delete and add columns like this. So that was pretty simple and straightforward. Hope you enjoyed the course. See you in the next segment. Hello students, welcome again to the new segment. In this segment, we will be looking at how we can concatenate the timetables together, both horizontally and vertically. So first look at how we can do it vertically. So remember, we have created the timetable, our timetable in the previous segment. So in order to concatenate them vertically, the only restriction that you need to have is that the two timetables needs to have the same variable names. So we can concatenate them together. And in order to concatenate them vertically, we need to say a column over here, and then we can match them. So now these three rows are concatenated and they are being repeated, right? For the horizontal concatenation of two timetables, we need to have, for the rows, we need to have the same timestamp. Moreover, for the variable names of the two timetables needs to be different. So let's create that, and we can say our timetable 2 now is equals to our timetable 1. So now it's a copy of that timetable, and within this copy I will change the names of the variables. I will call our timetable 2, and we can set the variable names and the properties. So we can say properties, and we can say variable names, and we can set them to some values. For example, we can say for the first one, we can say, for the second one, we can say some other value. The first one is not essentially temp, but let's say we can say temp 2, and then we can say, or alternatively, we can say variable 1, variable 2, and variable 3. So we have updated the variable names in the second timetable. So now we can concatenate them horizontally, because both the timetable, our timetable, and our timetable 2 has the same timestamps, right? So we can now concatenate them horizontally, and in order to concatenate them horizontally, we need to say it like this without a column, right? So now it will concatenate them together, but remember, when we are being concatenated, the order really matters. So the first one is this one, so this variable is going to appear first. And then this was our second timetable, so its variables are going to appear here, right? That is later on. And also remember that this row times are going to appear only once, because those were being common in both tables. So that's the essential difference between concatenation horizontally and concatenating it vertically and horizontally. So for horizontal concatenation, the variable names must be different, and the second condition is that the timestamps of the two tables must be the same. for vertical concatenation, timestamps does not need to be the same. However, the number of variables has to be the same. So those two are the prime conditions. There is also one more important function which is called the synchronize function, and it is used in cases where you want to concatenate tables horizontally and vertically at the same time. And additionally, there may be some variables which are repeated in both the tables, right? So in that case, we can use the synchronize function. So let's see how the synchronize function may work. So let's have a look at the our timetable 2, right? And our timetable 2 contains these three variables. So let's make one of these variables the same as date of the one of the variable here in our timetable. So we can change that. We can say our timetable 2 dot var 1. So we want to change the properties. And the property in this case is variable name, and we want to set the variable name of var1. We want to set it to the variable name of the corresponding variable in our this table, which is the our timetable. So in this case, its name should be timestamps. So now we have timestamps and timestamps in our timetable 1. So both of them have the same name, right? So we can now use synchronize function, synchronize, and we want to synchronize our timetable with our timetable 2. So when we press enter, we notice some interesting results. You might notice that now the combined table has now only 3 rows, while our timetable, it contains 3 rows. Our timetable, it also contains 3 rows. But you may have noticed that since the timestamp of these are the same, so they have been considered as a single rows, right? And since these variables were having the same time, the same level, so how it differentiated between the two is that it will automatically insert the name of the table over here. So timestamp, this was the variable from our this table, and this was the variable from this table. So if they have the same name, it will append the table name in front of it. Moreover, it also contains all the variables that we were having in the two tables. And it performed the horizontal as well as the vertical concatenation at the same time. With regards to the vertical concatenation, you may have noticed that all those rows which were having the same timestamp, they are appearing only once. So if by chance we have some other row which is different from this timestamp, so now that will be also part here. It will also be appearing over here. But again, there may be some values which are missing over here. So suppose if we have another row over here, but that row does not have the corresponding timestamp over here, so it will be part of here, but for these 3 variables, we will not have any value in this table. So it will be considered as a sort of missing values in this synchronized table. So it's quite useful in order to combine the two tables horizontally as well as vertically together. And the important point to note is that if we have the same variable appearing in the two tables, so then it is going to append the table name to those variables, right? And if we have a row, it is common that is having the same timestamp, so it is going to appear once. And if it has a row which is present in one table but not in the present, so some of the values here may be empty or missing here. Okay, so this was regarding the synchronize function. Hope you're enjoying the course. See you in the next segment. Hello students, welcome again to the new section and new segment of the course. So in this series of lectures, we will be looking at the table data structure which is available in the Matlab. So the table can actually hold different types of data. That is, it can hold numeric data as well as character data or string data or any other forms of data such as categorical or logical variables within the same data structure. So in contrast to arrays, that is the main difference of the tables. So let's see and go straight how we can define tables. So the first thing that you need to remember is that the tables needs to be created from the already existing variables, or you can import some data into the tables. So let's create few variables. Suppose the first variable is the age variable, and I define it as containing some values. Let's say 5 values, and now we can have another variable that is height, and it can also contain some value for 5, 9, and 10, let's say. So it also contains 5 values now. Similarly, we can have the weight variable, and it will hold some values. For instance, 85, 90, 78, 56, and 52. So now if you want to have a single data structure which will hold all the 3 values together, so for that you need to create a table. So you create the table by a keyword known as table. So that's the Matlab reserved word. That is, you cannot use it in your coding in order to create a variable name. So that's reserved. So we need to say t equals to table, and then we need to mention the variable names that we want to include in this table. So in this case, we have an age variable, and then the next variable is the height, and the final one is the weight. So when you press enter, it will create a table. So now if you look at what's the type of your different variables that exist, so it says T is a 5 cross 3, right? So it is a table data structure which contains 3 values: age, height, and weight. Okay, so there are different operations that you can do on the particular table. For instance, you can add the row names over here, and how we do that, we can either define a new variable. For instance, say last names, and it will hold the values for the names. For instance, my name, and let's say some other names. And one more, because we need to have 5 rows over here. So now we have 5 values for this last name. So now let's make them as the row names over here in this table. So basically we need to say t equals to this, and then we need to give it an option, which is the last names. And then we need to mention what we want to have as a last names. So that is stored within this variable. Okay, so actually we need to say last. We need to say row names instead of last name. So we need to say row names. And then when we display the table, you may note that we have our row names appearing here in this table as well, right? So, but it's not a good idea actually to every time redefine our table. So for instance, if you add something else, so this table will be redefined. Another way of doing the same is to say t dot properties dot row names. So now we can access individual elements or individual properties of this table using the dot notation, and we can set it to last name variable, which contains our last name. So it has essentially the same effect. Similarly, if you want to change the variable names, so you need to say here variable names, right? And then you can mention some variable names over here. If you don't want the default variable names. Remember that the default variable names are the names of the variable that you defined and included within this table. So let's have a look that we have the variable age, so it will now appearing as a default column name for that variable. So if you want to change that default, similarly the height was the name of the variable which contains these 5 values and weight. So if you want to change these defaults to some other value, you can do that. Suppose I want to say ages in foot, and I want, instead of height, I want to mention that heights also ages in years and height in foot, and then I want to mention that weight is in kgs. So when I press enter, you may notice that the variable names have been updated. But one thing more is that now the row names are not appearing here, and that's because we have redefined this whole table. So now this is according to the new definition. So one way of overcoming this problem is to mention the row names as well, and say the row names are contained in our last names variable. One way of doing it is this, but again the correct way of doing it is to, once define a table, don't change its definition, rather change it with respect to the properties. So change the properties, and in this case we want to change the property of row names, and we want to set it to the last name variable. When we press enter, we now have both. We have the names as well as this. So once defined a table, don't redefine it, rather change it within by using these properties. And with the dot notation, you can actually modify its different properties. One thing more is that default definition of a table is like this, that you have this table reserved for, and you assign it to some variable, for example t1, and then mention variable names, variable 1, variable 2, right? And these are your Matlab variables, and so on. And then once we mention all the variables, the next thing is that you need to say a name and then the value. So these are actually the names, for instance, the options such as the row name, column name, and there are so many other different properties that you can change. So these are the names of the properties of the table, and these are the corresponding values. So you can mention as many property names as you want, the corresponding value, and so on. So that's the general syntax of defining a table. Right? So essentially in this lecture we have covered how to define table data structure and how to set its rows and columns. So in the next few lectures we will be looking at some more useful operations on the table. So stay tuned. See you in the next segment. Hello students, welcome again to the new section and to the new segment of the course. In this segment we will be looking at how to create a timetable data structure within the Matlab. So essentially it's very similar to the table data structure, but essentially it contains some extra information as well. So let's look how we can do that. Before going ahead, it will be useful to mention that why we need this timetable data structure. So it is very useful in analyzing the data which has the timestamps with it. So for instance, you are getting some readings from some geographical area, and you are noting its different characteristics such as the temperature, the humidity, and so on. Or if you are analyzing some other data which has the timestamps, and you want to make your analysis based on the daily data that is being produced. So you need to actually have that timetable data structure. So it's going to take part in analysis of those kinds of data where you need to have a timestamp, and where you have a timestamp attached to the data. So let's see how we can do that. So if you recall, when we created the table, we noted that the table can be created from some of the existing variables. So let's define some variables. For example, I can create a variable called temperature, and which will keep record of some of the temperatures, and then we can create another variable, let's say locations, and this is string, so we need to include it in curly braces. And for the locations we can set, let's say, New York, London, and let's say Paris. So now our two variables have been created, and let's also create another numeric variable which will contain humidity. So that's it, 35, 56, some dummy values, and 89. Right, so this creates our three variables. Now, in order to create a table from these three variables, we can have a syntax like this. Timetable, we want to create a timetable. And the German syntax is like this. If we can mention variable 1 here, then variable 2 over here, then variable 3, and so on. However, we know that the variables in this case are the temperature and the locations, and then the humidity. However, while you are creating the timetable data structure, the first argument or a necessary argument for creating a timetable, which actually differentiated from a simple table, is the time value over here. Right? So we need to have individual times for each and every row of this timetable. So in order to create the date for this timetable, Matlab provides you with a built-in function called datetime. So this datetime can essentially take different formats. So one of the proper format is the year, month, and date. So basically, if you pass to it three values, for instance 2000, so it will convert the first one into, consider the first argument is in the year, the second argument is the month, and then the fifth argument is the particular date within that month. So if you press enter, it will say 5th of December 2000. Alternatively, if you pass to it an array which contains three values in each and every row, so it will correspondingly change it to the corresponding date. So if we look at it again and pass this data to this date function, so it will generate two dates, one corresponding to the first row and the other one corresponding to the second row. So essentially, if you look at the documentation of this function, so it can take different formats. For instance, you can give it argument in the form of relative day. So for the relative date, if you pass to it something like this, date time, and you say today, so then it will return the date of today. Similarly, the other relative arguments are yesterday, today, tomorrow, and similarly, it can also take other arguments. The other formats that you can look into is this format. If you provide to it 6 arguments instead of 3, so it will consider the fourth argument as the hour argument, and then the minute, and then the second. So let's see that as well. So for instance, if I give it 6 values, year 2000, month 6, day 2, and then the hour 13, minute 8, and the second 9. So it will convert it into this format. That is, it is 6th, 2nd of June in 2000, and it is 1 p.m. and then 8 minutes of within that hour, and then 9 seconds within that hour. Similarly, it can take other formats, and you can have a look at this documentation to see what are the formats. Right? And you can also define your own formats if you don't like some of the existing formats. So you can always define your own format, and you can use it. Okay, so okay. Remember, we have created those three variables which will be going to take part in our timetable, and these variables were humidity, the locations, and then the temperatures. So these three were our variables from which we want to create a timetable. And so the essential notion here is that remember that we have three rows here, so we need to create a date time for which will have three rows, right? So let's do that. So this is going to be the first row, and then we can have the second, and then we will have the third one. So now in order to create timetable, we need to say timetable, and then we need to pass the dates, but we made a mistake. We should have saved the date in a proper variable. So let's say times of day. So now we are in a position to create a timetable. We say timetable, and we need to specify the row times, which is contains in our variable times of day, and then we need to pass the other three variables to it. That is the temp, the humidity, and also the third argument, which was the locations. But please remember that the location was a 1x3 array, right? And since our table contains rows, so we need to take a transpose of that. So that will now all the variables have the same dimensions. That is 3x1, 3x1, and it was 1x3. Now it is 3x1 as well. So it will create a timetable. So you may note that the first variable now contains the time. That's the essential difference between a timetable and a simple table. So one of the columns needs to represent a time for an individual row. Right? So this is our first entry in the table, and we can identify this particular entry based on its timestamp. So similar to the second row and then the third row. So the essential point here to note is that we can the essential difference between a table and a timetable is that we do not have necessarily a timestamp for each individual row within the table. However, for the timetable, we need to have that. We cannot simply create it from a table, right? So one of the columns of the table needs to have the timestamp or the row time for that entry. So hope you're enjoying the course. See you in the next segment. Hello students, welcome again to the segment. In this segment, we will be looking at how you can use the time that is specified in each row to index a particular row, right? Or to retrieve a particular row. So it's quite simple. You can actually mention it as an argument, and you can say our timetable retrieve the data that corresponds to a particular date. So we can always mention the date here, and then you can say all the columns. Let's look at our data, our timetable. So we have defined our timetable. So let's look what kind of data we have. So okay, so we can choose the data from 8th of November 2000. So you can always mention that I want data corresponding to this particular date. So it will retrieve the data corresponding to that particular date. So recall that if you have a lot of data with thousands of records, so it is quite useful to index based on the date of time. Similarly, you can always mention the range of times that you are interested in. For that purpose, you need to use the time range function and assign it to some variable. So let's say we say time range. That is our variable, and we use the function time range. And in this function, we need to provide the initial and the final ranges that we want to retrieve the data from. So let's say we want to have 6th of November 2000, and then we want to end it to 7th of April, that is 2002. We want these two ranges. We want the data to be extracted in these two ranges. So this gives us a time range. So and then we can use it in order to select the data. So how we can do that is that we can set that variable over here, which is our time range, and then based on this range, select all the corresponding columns. So now it will retrieve two pieces of information to us. One row and the second row, which confines to that particular range. So that's it for this segment. See you. Hello students, welcome again to the segment. In this segment we'll look at some more properties and general descriptions of the table. So one of the properties that you can set is the dimension names. Right? So you can say t dot properties dot dimension names, and then you can mention what you want to call the rows and what name you want to suggest for the columns. So in this case, I want to name the rows as students, and for the columns, I want to give a name data. So remember, it's not going to appear in the summary. Rather, if you look at the properties of this table, it will appear in the name. So we may look at the properties by saying t dot properties, and it will display the values of all those properties that we are having. So dimension names are student and data in this case, right? Similarly, we may be interested in adding some journal description for this particular table. So in order to do that, you need to access the description property. We need to set it to some value. This table contains information about students, and you can add a lot of different information. So this will store the description, and you can see this description in the summary. So it's again a kind of a metadata, that is data which is not which is about the data, which explains about this data, right? So this is the description of this table. That's it for this segment. See you in the next segment. Hello students, welcome again to the new segment. In this segment we will be looking at some more operations that we can perform on the timetable. And majority of these functions and operations, they are very similar to in syntax to the operations that we performed on a simple table. So let's do that. So the first operation that we can do is that we can add or delete a column from the timetable. Remember, we have created one of our timetable in the last segment, so we can use that. So this is our timetable, and now we want to add a column to it. So we can use the dot operator in order to do that. So we can say our timetable and then dot and then the name of the new column that we want to add. So we want to add another 5th column to it, and then we can mention some values that we want to add with it. And so our timetable dot 5th column. So it will add another column to it. If we want to delete this column now, we can do it in the same way, and we can say our timetable dot 5th column equals to empty matrix. So it will delete that 5th column from our timetable. So similarly, we can use the sort rows function that we previously defined when we were studying the tables. And if you pass to it the timetable, so, and if you don't mention any arguments, so by default it is going to sort this timetable based on these timings, right? Alternatively, you may want to sort it based on some variable, for instance the temp. So it will now sort them based on this variable, and by default it is in ascending order. You may want to descend. You may want them in descending order, so you can always mention that. And recall all the other alternatives that we have studied in regards to the table. You can apply all of them here, all of those different options. You can also try it over here. For instance, if there is a draw between two values over here, then it looks for the next variable that is in front of it, or if you want specific some other variable to look for, so you can always mention that over there. Right, so there are different options. You can try them out. You can also do manipulation on individual columns, and you can say our timetable dot. Suppose I want to modify the values of the temperature, and I want them to be multiplied by some value or some constant. So I can always say our timetable dot temp multiplied by 8, or suppose it is in Fahrenheit, you want to convert it into Celsius, so you can always apply the formula over here and press enter, so it will do the operations on that particular column. Similarly, you can also access some portions of the data of the timetable using the colon operator. So, for instance, I am interested in only the first two rows, so I can say 1 to 2 corresponding to all columns. So it will return only the first two. So you can always use its different combinations. For instance, I am interested in the first two columns as well, so it will reduce it. But remember that it is not treating this as a column; it will always be appearing, right? So you cannot take rid of that. So similarly, you can do you can define different types of customizations, and you can apply it to select different portions of the data. Similarly, we can apply the logical operations on this particular data and select our data accordingly. So all the operations that we performed on the table can also be applied on the timetable as well. Similarly, we can also set the properties of this timetable in the same way that we did for the table. So for instance, I am interested in changing the variable names, and I am interested only in the variable name R3, and I want to update it to some more meaningful value, so I can call it locations. Alternatively, if I am interested in changing the variable names of all the variables, so I can say variable names without having any arguments, and then I can update them like this. And so now we have new names for our variables. Remember that this is not going to be changed, right? So please consider this as your variables, not this type of constant kind of a thing. You can always add data and look at the summary of your timetable. So this will generate the corresponding summary of your timetable, right? Similarly, you can modify the other properties of your timetable. Similarly, you can modify the other properties such as timetable, such as the description. Remember, we covered that when we were covering the tables. You can add useful description. This table, timetable, contains information regarding temperatures at different locations, right? So you can add whatever you want. So we need to say it with the we need to use the appropriate tags. We need to say properties dot description. So it will aid the description. In order to see the description, we need to look at it in the summary. So the description will be there appearing at the top of the table. Similarly, you can add a description for your individual variables, and the syntax is quite similar. you need to say it variable description, variable descriptions, and then you can add description for your variable 1, and then variable 2, and then so on, right? So this will separate the description of different variables, right? And you can add something here, and something over here as well. Similarly, you can add the variable units in the same way that we did it when we were covering tables. So this is going to be stored as a metadata about your table, and then finally you can always import this metadata using the eval C function, and you can say summary of our table, and then you can assign it to some variable, and then fprintf to a file. Right? So essentially you can do all the stuff that we covered with regards to the table, and you can apply all those stuff within on your timetable as well. So you can do all the manipulations. In the next few lectures, we will be looking at some more interesting operations on the timetable, so stay tuned. Hello students, welcome again to the new segment of the course. In this segment, we will be looking at how to read and write data to the tables. Right, so let's see how we can do that. So suppose you have some data that has been stored on your hard disk somewhere. So I have these two files. One of them is in CSV format, and the other one is in the XLSX format. So let's see how we can actually read those two files. In order to read a table, you need to use the function read table and then specify the name of the file and the exact location where it is located, along with its extension, and then you can read it in some variable. Suppose I am reading it in X. So now it will read this data into this variable. So now let's see who's X, and X contains the value. So if we display X, it has all the values. So similarly, I have also defined another data set which is in XLSX format, and this is my data too. So now if we look at this again, you may notice that it also has this, it can also be read into this variable X. Right. So let us look at some different options that are available while you are reading the file. So suppose if I do not want to read the name of the variables, so how I can specify that? Well, I can say read it, but actually I do not want to read the variable names, so I need to mention it here, read variable names, and I need to set it to false. So now it will not read the variable name. So if we display X again, you may notice that the variable names are not appearing here. Similarly, if we delete the first row of our table, so this is our table, which in the first row contains the variable name. So if we delete it and then save it again, and then if you read it, so now it will say, it will give it default values for the variable names. So we do not need to mention that in this case. So now the variable names will be set to defaults, which is var 1, var 2, var 3, var 4, and so on. So it's not the corresponding file, I believe. The corresponding file that we modified was the CSV file. So we need to say CSV and then iris, and then let's look at it. So now it has the variable names var 1, var 2, var 3, var 4, var 5, and so on. And so essentially you can use this read table function in order to read different types of data. For example, the .date, XLSX, the CSV format, and so many other formats. If your data somehow is in a .txt file and you know the delimiter which actually separates two values from each other. So you can also mention that over here, that the option is delimiter. So the correct spelling is, you need to capitalize D in the limiter, and then you need to mention what is the delimiter which separates two values from each other. It can be a space or it can be a special character. So you need to mention that read this file which is in txt format, and the delimiter that I am considering is, let's say, comma or any special character. So let's have an example of that quickly. So I have my sample data over here, and I just create a new copy of that, and I will save it with the .txt extension. So now it means it's a text file, and when I open it, I see that the delimiter in this case is a comma. So when I try to run this, it's going to work for us. So now if we look at X, it contains the same values. So alternatively, my delimiter can be any value. So suppose if I replace the commas with, let's say, a backslash and replace it all. So now my delimiter is changed to backslash. So we can always change that here and say the delimiter now is a backslash. And when we press enter, all the values are in our variable X. And then we can apply the different properties, and we can set the different properties that we learned in the previous lectures. For example, we can always give names to the rows, and also we can change the names of the variables, and we can do other manipulations that we learned in the previous lectures. Now let us look how we can write the table back onto our hard disk or our memory. So you need to use the function write table, and you need to mention the table name and then the location where you want to save that. So in this case, I may say this is our table 1, so I will say table 1, and then the format in which I want to save it, which in this case is .txt. If I want to have some particular delimiter, I will also mention that. So delimiter in this case is a comma. So when I press enter, it is going to write for us. So we may look now back at our hard disk where actually our data is located. So this is basically our file which we have just stored. So remember, you may notice that the default variable names are also being stored along with this table. So if you want to get rid of that, you can always mention that as an additional argument while you are writing that. So you can say variable names, and you can mention and set it to false. So don't write the variable names. So you can say write variable names equals to false. Write variable names, and then you can set it to false. So now it will not write the variable names along with the document. So when you press enter and look at the file again, this one, so you don't see any variable names in the first row of your corresponding file. Of course, there are a whole bunch of other different options that you can try with the write function. So remember, we have created this table. So let's look at how we can actually store the row names as well along with this table. So by default, it will not store that. So let's have a look. We want to store this, and we want to give it a name table2, and the delimiter is this. So when we write it onto our memory, it's not going to store the row names. So the row names are not there. Okay, so we made a mistake. We should have said table T over here. So now let us look at it again. Inside the memory, it has those variable names, but it does not contain the row names. So if you want to store the row names to it as well, we need to mention and give it an additional name value here. In this case, which in this case is write row names, and we need to set it to true. So when you enter it and look at the file again, so you may notice now that we have the row names here as well. So essentially you can look at the documentation of this particular function, that is the read tables, and here you can actually read tables and write tables, and you can actually look at different name value pairs and apply it based on your customization. Similarly, you can look at the write tables and look at the different name value pairs that are available and apply it and try to do different kinds of manipulation based on that. So that's how you can actually read and write tables to and from your memory and manipulate it. Hope you're enjoying the course. See you in next segment. Hello students, welcome again to the segment. In this segment, we will be looking at how you can select portions of the table and do some manipulation on top of that. For instance, you may want to select some particular rows or some particular columns from the table. So remember this table, we have created it in the last segment. So let's now look at how we can actually select some of the rows or some of the columns from this table. So for that purpose, we can actually use the colon operator, which is this one. And with this colon operator, we need to mention the initial point and the end point. So for instance, if we say 2 to 10, so it means the numbers from 2 to 10. So if we say T and then mention 2 to 4, so the first argument here, it will represent the rows that we are trying to select. And if we say it without mentioning the initial and the final, and the second argument is for the columns, so if we don't mention the initial value and the final value, so in this case it will select all the columns. So this essentially means that select from row number 2 to row number 4 and all the columns. So if we press enter, you may note that only from 2 to 4 has been displayed. So if I want to mention from 2 to 3, so now it will give us only the second and the third column corresponding to the first, corresponding to the row 2, 3, and 4. So now we have, similarly you can think of so many other values and so many other things. Similarly, we can also do like this, that if we want to select from row 1 to row 5, but we want to select only the odd rows, so we can mention that. And in this case, it will select from row number 1 up to row number 5 with a space of 2, right? So it will select row number 1. If we look at T itself, so it has selected row number 1, and then it did not select the second one, and then it select the third one, and then it does not select this one, and then it select this. So what essentially means 1 to 2 to 5 is to generate numbers from 1 to 5 with a step size of 2. So in this case, it has select row number 1, row number 3, and row number 5. Similarly, if we are working with a very large table and we do not know the end point of that table, so and we want to manipulate it like that, so in this case we can always mention the special reserved word end. So whatever the size of the table is in this case, it will be represented by the end value, and then it will do selection as like this, that row number 1 will be selected, then 3, then 5, and so on. Right. So similarly we can change the order as well, and we can say let's select starting from the end, do not select 1 and come all the way up to row number 1. So it will now reorder the selection. Right. So it has selected the last one first, and then it does not select this one, and then it selected this one, and this is skipped, and then this one was being also selected. So this was an easy way how you can actually select different rows and different columns. Similarly, uh, if you want to rearrange the values over here, there is the column names. You want to rearrange these columns, so we can also do that with the column operator, and we can say T corresponding to all rows. I want to mention that okay, my column number 1 will be column number 3, my column number 2 is going to be column number 1, and column number 3 is going to be column number 2. So I can mention that order over here. And when I press enter, you may notice that the column number 3 is now appearing in the first position. The column number 1 has been shifted to column number 2, and column number 3 is our column number 2 here, that is height foots. So this way we can rearrange our variables in the table environment. In the next few segments, we will be also looking at some of the more complex ways to make selection of rows based on some condition, right? So that will be based on some logical operations. We will learn that in the next few segments. So hope you're enjoying the course. See you in the next segment. Hello students, welcome again to the segment. In this segment, we are looking at how to sort the table rows by selecting different variables. So let's see how we can do that. Remember the sort function, so we can actually use the sort rows function to do that. And if we pass it the table, so by default it is going to take the first variable, that is the age years within this table. That's the first variable, and it is going to sort it based on that variable, right? So here are more than 2 values having exactly the same values, and then it will look at the second variable and try to do that based on that. Alternatively, you can mention a particular variable name based on which you want to sort the table rows. So in this case, we will mention that sort T, but sort it based on the variable which is height foots. So now it has sorted it in ascending order based on this variable which is height foots. The default option here in this sorting is the ascending order. You may be interested in sorting it based on the descending order. So you need to say sort rows, mention the table name, and then the variable based on which you want to sort, and then you need to mention additionally that whether you want to sort it in ascending or descending order. So in this case, I want to say a descent. So now based on the height variable, we may look at it that the rows are now being sorted based on the descending order. Similarly, we can mention here that we want the sorting not based on any variables, but based on these row names. So in this case, we need to say row names here. And again, you can choose from ascending to descending order. If you don't mention descent, then by default it is going to be in ascending order, right? Of course, this sort rows can take many complex forms. For instance, you may be interested in that first of all sort the values based on the variable height foots, and then ages underscore years, and then we need to close it in brackets because there are multiple arguments. And then we need to say that okay, for the first one I want it to be in ascending order, we need to have capital A over here, and then descent. So what essentially this means is that it will first sort the rows based on this variable height in ascending order. So this will be in ascending order. And if there is a tie between two values. For instance, there is a 5 and there is another 5, or there is a 10 and there is another 10, so that it will look and conserve the age variable. And then whatever the age value is greater, it is going to take date first. So it will do the descend operation on that. So in case of ties on height, it will look at the age variables but in descending order. So that's the essential meaning of that. And so similarly, you can think of any other complex combination over here, and that will work. So that was about sorting the rows. Hope you are enjoying the course. See you in the next segment. Hi students, welcome again to the new segment. In this segment, we want to show you that how we can actually store the summary of the table. That is the metadata that we have created alongside the table. So recall we have generated this table, and we have a lot of metadata that we have included in this table. That is its units, its description, and its sizes, its mean, median, and max values, and so on. So if you want to save it, remember that you cannot actually define a variable and say the result you want to store in that variable. It's not allowed. It will give you an error message because it does not work like that. And so it will give you an error message. So what's the way around of doing it? Well, the way around is to assign, we will use the eval C function, and it will actually evaluate whatever input argument you give to it, and then it will save it in this variable. So it does not return anything for you into which can be stored in a variable. However, when we run it like this, the result is going to be stored in this particular X. Right? So it's a way around of saying the same thing, but a little bit differently. So it will return a string array, character array, which will contain all the information. So now X has all the information. If you want to look at it, it has all the information, right? But remember, it is in character form. So it's not a cell array or any other data structure. It's simply an array of characters. And if you want to look at it, you can have a look at it that X is basically 1 cross 803, which means it is a row vector and it is a character array. So if you want to store it, you can use the fprintf command, and for that you can always open up a file. So remember these functions fopen, fclose, these are part of the basic Matlab course. So you can either register that course or just look at the help and see how they work. So we open a file. We call it summary.txt, and we open it with the write access to it, and then we say fprintf, and then we pass it the file ID, and then we want to say that okay, here this is going to be a long strings, and here want to X to be printed to that particular file, and then we want to close that. And then if you open up your directory and you go to the view directory, you will have a look at, okay, we have that file which contains all the summary. So if we open it in a proper editor, we can have the proper units. So this is all the information, the description, the units, the median mode, the mean, median, and the max value, and so on. So this was actually a way around for saving the information and the summary information of a table. So remember that you cannot use the syntax because it is not a valid syntax that has been defined in the Matlab. So the way around is to use the eval function, the eval C, and it's actually evaluates whatever the string you pass to it, and it will evaluate that and then store the result into a corresponding variable, and then it is stored as a vector, as a character vector, and then you can print it out to your text file. Hope you're enjoying the course. Move to the next segment. Welcome again to the new segment. In this segment, we'll be looking at how we can concatenate the two different structures together. So remember, the only restriction with regards to the concatenation is that the structures that we want to concatenate, both of them should have the same fields. That's the only restriction. And the data types of those fields may be different, right? So that's not a restriction, but the only restriction is that the only fields of the two data structures that you want to concatenate should have the same fields, irrespective of the data. So let's do a simple example. We can say that S1 is our structure 1, and we define it like, let's say it has two fields, S1.a equals to some numeric value, right? And we say S1.b, it contains some other value, let's say A, B, and C. So now it is a cell. One thing more that you should note is that previously we were using the reserved word struct in order to first define a structure and then assign its different fields to different values, right? But one way of doing that directly is that if you don't mention the data type, right? So we know that by default, the Matlab will do a good job at recognizing what kind of data type it is, right? So when it encounters a dot notation, so it automatically recognizes that it is going to be a structure. So in this case, if you do not define it, the Matlab will automatically define it for you, right? So it will say that S1 is now a data structure and this is a particular field, and now it has three values that has been assigned to it. And we can always access that by saying S11, which is the first element of the data structure, and we can always assign different values to it. Okay, so now let's have another structure. We call it S2, and we say S2.a equals to, let's say, rand 3. Remember, the rand is a built-in function which will generate a 3, 3 matrix, and will assign that to the element of the particular structure. And then we say S2.b, and it contains some more values, let's say one value, and it came hello. So now if we look at S1, S2, so both of them has two fields, A and B, but the contents are quite different. Okay? So if we want to concatenate them together, we can say combine, or we can say combine structures. Combine S1, S2. So now in this case, it will combine the two, and we can always use square brackets to combine them. And we can say S1, S2, so it will combine these two structures together. And now we have a combined data structure which contains two rows and it has two fields. Okay? So in order to look at the individual elements of this, so we can say combine S1, S2, and we want to access the first element of that. So if we look at it, so it will give us the two values corresponding to the first element of S1, right? So it is essentially equivalent to S1 and saying 1, which has those two fields. If you want to look at the contents that are being part of S2 structure, so we can say this 2 here, and then it is the same as saying S2, so that has those two pieces of information. One thing more that you may have noticed is that the sizes of these particular structures, so S1 was of size 1 cross 1, which means we are having only one entry in this S1, which essentially, if you double click it, it will give you more intuition regarding that. It says that it has only one instance of that, and it contains these pieces of information. Similarly, but if you click on this one, so now we look at it that it contains two fields, A and B, and then the first element of the structure is this, and then the second element of the structure is this. Right? So it is now 1 cross 2 structure. It has two rows corresponding to one column. So that's how we can concatenate two structures together. The essential idea here is that the two structures should have the same fields. However, it's not important that if the fields have different data structures. So that's it for this segment. See you in the next segments. Hello students, welcome again to the new segment. In this segment, we'll be looking at some more tricks with the container, map container. So the first thing that you may know is that the container may contain different kind of values, right? It can be random, it can be array vector, or it can be a character array. So the three values are now in this case they are different. With the range function, we need to mention those as well. So yeah, right. So if you look at the contents now, the contents. So we said that corresponding to Jan, we have a row vector corresponding to Feb. We are now having a column vector, and corresponding to the third element, we now have a character array. Right? So essentially, the values can be different. They may contain different data types. Okay. If we are interested in removing a particular keys, so that their values will be automatically deleted as well, and we need to use the remove function for that. So we need to say my container, and for my container remove the keys or a key such as Jan, so it will remove that. So if you look at your my cont again, so my cont, and you want to access the Jan, so it will be an error that it does not exist. And corresponding, its value has automatically been deleted. Right? So the Jan, it was initially containing a row vector, so that row vector you don't need to specify that, please delete that as well. Similarly, if you want to delete multiple keys, so then you need to use this syntax that is just included with the curly braces, and then the individual keys will go here, right? So it will delete all of that automatically. There is another function which is called isKey. So you basically is asking the question that whether within this container variable do we have a key with this, such as this. Right? So it will say either a logical 1 or 0 depending on whether it's present or not. Similarly, you can always pass to it the multiple keys to look for. For example, merge, so this one will say yes, and for this one it will say no. Right? Because we have merge, not merge. So now it is 1, 1. We can also concatenate two containers together. So let's do that, an example of that. So we created this container earlier. Right? So let's say we define a container and say count 2. And then we make some adjustment to the names. And then we say this is for April. And this is for May. And this is for June. And then correspondingly we can also make some amendments to the name which will always be changed. So let's say 10, 15, then for, and then press enter. So if you want to concatenate the two containers now, the container maps variables, so we can do that. And we can say my container, and after that append with my container 2, my large container. So the result will be stored here. So now if you look at the size of my large container, so you can say who's my large container, and it will say it has now 6 rows. Right? Similarly, you can have a look at its keys, my large container, and it will have 6 keys. Right? So 4 of them are being present here in the corresponding resultant container. One Well, one note that is very important to remember is that if we have duplicate keys in the two containers that we want to concatenate, for instance, January, and there is another January over here, so then it will discard one of the values. Okay. So let's do that example as well. So here let's create a duplicate entry, and we call it Jan. So now Jan is present in both the containers. Here we have Jan in my count 2, and also we have Jan in my count. So if we add the two now, concatenate the two, and then look at the individual keys that are present over here. So we have 3 keys in the my container 2 and 3 keys in my container 1. So if we look at the keys in 2 containers, the result, that is the concatenation result in the my container. So you may note that it has only 5 keys, 5 unique keys, while we were expecting 6, right, in this case. And if you look at the values here in this my large container, so now it contains only 5 values. So remember that for the my container, the values were the individual values were 3, right? So hello, 3 cross 1 and 1 cross 3, while here one of the values have been discarded, right? And that value, if you look at the contents of the large container, which is large container, so remember my large container. And if we investigate the contents corresponding to Jan, so we may note that it contains a 1 cross 3 matrix, while here in the my container, we were expecting a 1 cross 3 matrix over here, and similarly for Jan that will be defined over here, it also contains, let's look at the values here as well. So my count corresponding to Jan, it contains the 3 values which are different here from this, and this may correspond to my container 2. Right? So these values in the large container, which corresponds to January, now corresponds to my container 2, and we have lost the values that were present in my container 1. Right? So whenever we say, when we concatenate the 2, so one of the values has been lost. So that's the problem with the duplicate keys. If you have duplicate keys, some of your values may be lost. So better avoid that, and make sure you do not have any duplicate keys while you are concatenating the 2 containers. Hope you are enjoying the course. See you in the next segment. Hello students, welcome to the end of the section and to the segment of the course. Here in these series of lectures, we will be looking at another data type, which is called containers, made containers. Earlier we have noted that we have already covered the structures data type. So this made container is essentially very close in interpretation to the structures. The essential benefit of using this container map is that, in contrast to other data types such as the matrices and arrays and the cells, where we need to remember the individual indexes such as 1, 2, 3 and so on, which is in numeric form, in order to access a particular data item, we need to remember its corresponding index. So here it makes it more meaningful, and by giving it some meaningful name, we can always use that index to retrieve a particular data. So let's see how we can define it. So the first thing is that you give some meaningful variable name here, right? And then you say the result equal to containers dot map. So remember that this dot is an indication of structures in Matlab. And then you can say, please create that. So it has created an empty an empty container, right? So if you want to initialize it with some meaningful values, so you can always do that. So let's say we want to have some meaningful values. So remember that the first argument here is going to be the keys or the indexes that we are going to use for retrieving our data. And then the next item can be some values. So it has now created, remember we need to use S over here as well. So now if we want to retrieve the first data item, so how we can do that? You can use your variable name, my container, and then provide it with the corresponding index, which is January. So now it will retrieve the corresponding value. So similarly we can do fab, and it will retrieve the second value, and so on. So you can keep on adding values over here. Remember that these values can be of any kind, right? So they can be cells, they can be integers, like floats, characters, and so on. Alternatively, they can be vectors as well, or individual matrices as well. So let's do a simple example of the case where these are not simple values, but a little bit more complicated values, such as vectors. So let's define a random variable of size 3 cross 3, and then we go again into our definition, and then we say that okay, the first element that is going to be part here is our x and the entire first row. So in order to mention the row, we need to say it like this. So this dot means all the columns, and this means the first row. So the first row is now going to be stored against the first key, which is January. So we may have some readings in January, which they may represent. And similarly, for the third, we need to have. Okay, so now our 3 rows of this matrix are going to be retrieved when we mention January as an index to our container. So let's access that. So if we say fab, it's now going to retrieve the second row corresponding to this matrix. So now we have the values as a little bit more complicated data type, which is a matrix, a row vector in this case. But remember that one thing you need to make sure is that the number of keys should be equals to the number of values. Otherwise, it is going to give you some syntax errors. Okay, so it stores the data corresponding to key value here, right? So it stored it like a key value here. So the number of keys should be the same as the number of rows over here. Right? Similarly, you can always mention numbers over here, but again, it will not make sense to use containers if you are using numbers over here, because for that we already have other data types, matrices and cells and so on. Moreover, these can be cells as well, right? Or any other type of data that you make. So if you want to look at the individual keys that are present within your container, variable, my container, so you can ask, you can use the built-in function keys and pass to it the my container. So it will say these are the individual keys that are part of this container. Similarly, you can say values, and it will give you the individual values that are present within your container. Right? So it says they are composed of 1 cross 3 cells. Right? So we noted that we passed to it already row vectors which contain 3 columns. So they are located over here. So similarly, you can add or remove items from the container, do some other manipulation on top of that. We will see that in the next few lectures, so stay tuned. Hello students, welcome again to the new section and to the new segment of the course. In this series of lectures, we will be looking at a very important data type that is called structures. So the structures has essentially so many different benefits compared to the other data structures such as the cells and arrays and matrices and so on. The essential difference is that here you don't need to remember the indexes, and you can actually reuse the structure in order to store more data into that particular element. So the structure essentially provides you with a skeleton, and you can actually use it as many times as you want, and without remembering the indexes, and you can easily access different data that is stored within the structure data type. So in order to define a structure, you need to use the reserved words struct, and then according to the definition, you need to mention values in the form of fields, and then comma value form, right? So the field essentially means it will serve the purpose of as an index into a particular element that you want to have within that structure. So let's do a simple example, and I want to call this structure as a student structure, and corresponding to student I have different kinds of data. For example, the first data can be his date of birth, and then the corresponding date of birth. Similarly, I may also be interested in the age of the student, and for now I want to keep 20. And then finally, I may also be interested in the grades that he has obtained, and for now I also want to keep empty. So when we press enter, you may notice that the student data structure has been created, and it says a 0 by 0 empty structure array with the following fields. So now if I want to store the data of student 1, I may actually give it the values of these fields, and it will be automatically stored over there. So if I say as student 1 dot date of birth and enter some meaningful value over there, for instance I say 2012 and 5. So now we have the student 1 data, and the student 1 data has the date of birth field. However, the age and grades are not being set. So similarly, we can also set the age variable, the age field, and I will call it, let's say, 17. So now we have the age value as well. So similarly, we can do the grades as well for the student. We can set the student grades. So we can say student 1 dot grades equals to let's say 80%. So now we have all the values corresponding to student 1. If you want to reuse the same structure, you can actually store the data for student 2, and we don't need to redefine all these variables. So we just can add the value for student 2, and we can say student 2, and let's say his grade is 90%, and his corresponding, let's say, student 2 age. So age is, let's say, 18 years, and then we can also mention that student 2 dot date of birth, at date of birth, so it is equals to, let's say, 1999, 6,6. So now we have all the values corresponding to student 2 as well. So if you want to have a look at the student 2 data, we can just have a quick look at that by just mentioning 2 over here. So we don't need actually to remember all the indexes corresponding to all the different fields. And similarly, we can have a look at student 1 data, and that was being stored over here. Right? So this represents student 1 data, and this represents student 2 data. So the essential difference here is that every time we do not need to redefine the structures and the data types. It has been automatically taken care of, and we can define as many instances as we want. Suppose we have 100 students, so for each and every student we can store the data in this format. Right? And it's quite easy with the documentation to remember which fields we are referring to and what's the corresponding data type of that. So now if we are interested in the student 1 data, we can mention it over here, and it will return all the corresponding data. Similarly, if we are interested in a specific field for all the students, so we may just be interested in the date of births, right? So we can mention it like that, and it will return only the date of birth fields. You made some mistake, yeah, the birth field, and then it will just return the birth field corresponding to the two students. Similarly, we may be interested in the ages, so it will return the ages of the students. So that's how we can access a particular field within this particular data structure. One thing more is that if our particular field contains not a single value, but rather a matrix, or let's say a character array or a string array, so we can actually access the individual elements. So for instance, if I say student, and I know that the date of birth of this student is a string, and it contains 1, 2, 3, 4, 5, 6, 7, 8, 9 values. So now if I want only to access the first 4 values out of that, so we can mention it with the indexing that we are familiar with, and it will now return the first 4 values of that. Similarly, if it is a matrix, we can index it properly and access the appropriate values within that particular field. Right? So that was a little note on how within the field indexing is also possible. So hope you're enjoying the course. We will return with some more operational structures in the next few lectures. So stay tuned. Hello students, welcome again to the new segment. In this segment we will be looking at a few more tricks and techniques that you may apply with respect to the structures. So the first thing that I want to mention is that if you have an existing variable, you can make it and assign it to a field of a particular structure. So let's say we define the structure, say structure 1, and then for the structure 1 I want to assign a variable that is a 3x3 random variable. So let's say this is our variable a, and then I can say structure dot a equals to a. Right? So now what this means is that it will create a structure, and it is a particular field of that structure, and it will be assigned this value. Right? So similarly, you can assign any variable and make it a field of your structure. So there are some more important functions. The first one is the isField function. So it will return logical 1 or a logical 0 depending on the structure and the field value that you are passing to this function. So let's do a quick example. Remember that we created this structure in our earlier examples. So now we want to determine that whether we have some fields, let's say the H field exists within this structure or not. So the first argument to this function is the structure name, and then the field name that you want to check. So it will return a logical 1. If we say S there, so it will say no, right? The other syntax for using the same function is to pass it a list of different names, and then different field names, and then it will return 1 or 0 corresponding to every field name, right? For example, we say the next one is subject, right, with a smaller s. So when we press enter, what exactly it means now is that the first value that you pass to me as an argument, so it is a field within this structure. This is also a field of this particular structure, while this one is not a field of this particular structure. Remember, this is case sensitive, so S needs to be big in order to, and there should be an S at the end as well, so it has to be exactly the same name as the field. The other useful function is to check whether a particular data element is a structure or not. So for that purpose, you need to use the isStruct function, and then you pass to it the structure name. For example, if you pass to it student, it will say yes. However, if you pass to it students, it will say no, right? So it says undefined variable. So if you pass to it some other variable that is in our workspace, for example C, so it will say no, right? It is not a valid structure. Similarly, if you pass to it some other, let's say V1 is also going to be used in our workspace, so it will also say no. Instead, if you pass to it S1, which is a structure, so it will say yes. So these two can be useful, can be used inside the code to check whether a particular field exists inside a particular structure, or alternatively, if a particular data element is a structure or not. So hope you're enjoying the course. See you in the next segment. Hello students, welcome again to the new segment of the course. In this segment we will be looking at how we can actually make a reference to a particular item that is being present in a particular field of the structure array. So let's straight go to that. Remember, in the last lecture we have created this structure which contains different pieces of information for a particular student. For example, his date of birth, his age, and his grades. So now let's make it a little bit more meaningful and we add a field to it which we call the subjects. And usually it's empty. And then we can actually look at the grades as well. So let's create the structure. So now we have 4 fields inside the structure. Suppose I'm interested in, I want to add some data for student 1, and for the subject's part, I add some information in the form of a cell array, and we call it, let's say, English, and then another element, I call it math, and then another element probably something else such as science, and then one more, let's say, general knowledge. And now, corresponding to this information, I also want to add the subjects that the grades that he has obtained corresponding to these different subjects. So I need to modify the grades field, and then I will assign some values to the grades. So for instance, in English, he obtained 80. In math, he obtained 70%, and then in the science, again, let's say 85, and then in general knowledge, 90. Now we have different fields that are being set corresponding to the student. Yes, we have made a little bit mistake while we were actually trying to say the subject, so we forget this S. So as a result, it has created a new field within the data structure. So sometimes if you misspell it, so then you can always delete that field by using the function rmField, that is remove field. So you need to pass the data structure to it, which in this case is the student, and then the second field is the name of the field that you want to delete. So in this case, I want to delete the subjects field with an S, so it will delete that. So now we have the corresponding data structure. Okay, so now let's get back to the original point where we wanted to say that we want to access the data within the particular field. So in this case, the field may be the grades, let's say. So if this is a grade and I want to access the first grade, right? So I can use, if it is a matrix or an array, I can use these smooth braces and use a proper index in order to retrieve the data item from here. And so similarly, if I say 2, I can also grab the second data from the field. Similarly, you can obtain different operations that we have learned during the Matlab learning. For instance, you can compare it with some values, or you can apply some multiplication on top of that. You can say multiply by 8, so it will return and update the value. Right? So the other one is the cell data structure. So remember that when we were covering the cells, so we said that in order to index a particular item, and if we use a smooth braces, so that it will return the sets of cells. Right? So if we say subject and then we say 2, so it will return a cell map. If you are interested in the original value, the value that is being contained over there, so remember we use the curly braces over here, and you can always do that and return the actual value, not the cell data structure, right? So that's how we can use the indexing in order to create some data item within a particular field of a structure. Hope you're enjoying the course. See you in the next segment. Hello students, welcome again to the segment. In this segment, we're looking at how we can actually retrieve the data from a particular field of a structure and how we can store it meaningfully in different variables. So let's say we have a structure and we'll call it S1, and before that I will clear all the variables in memory. And so I will say S1 dot A, and it's equals to some value. So let's say I will assign it a numeric value 1, 2, 3. Right? Next, I define the second instance of that same structure, and for the second element, I assign only the value, which is let's say a character array in this case. And similarly, for the third value, I may assign a different value. For example, I may say rand 3. So now if we look at S1.a, all the three values are different. This is different, this is different, and this is different. So now if I want to retrieve these three pieces of information and want to store it in some simple variables, so how I can actually do that? So one way of doing that is to define an array of variables. So I say variable 1, variable 2, and variable 3, and this is equals to S1.a. So the three values here, it will be the first value will be assigned to this variable, the second to this one, and the third one to this one. So that's one way of doing it. Right, so now if we look at V1, so V1 is containing the first value of S11.a, and then S12.a, it contains hello, and S13.a, it is stored in variable 3. So that's one way of doing that. Please remember that we cannot directly assign it to a variable and say like S1.a, right? Because S1.a contains three different pieces of information. The first one is a 1 cross 3 matrix, and then we have a character array and then a 2 cross 3 matrix. So it is going to say that undefined. It is going to be retrieving only the first values. So instead, if we want to get all the three values, right? So it will be not working. One other way to retrieve the different values is to use the cell array. Remember when we were covering the cell array, we noted that the individual elements that are part of the cell can contain different types of data. So in order to retrieve the data from the structure S1, we will enclose it in curly braces, which is an indication of the cell, and then we can say C equals to this. So it means that convert this data, which is present here in these curly braces, it will be converted into a cell, and then it will be assigned correspondingly to a C variable. So now C contains three elements, and the first element contains, if we want to access the first element, we may look at it, and we may say the first one. So it contains the value 1, 2, 3. Similarly for the second element, it contains hello, and then for the third element, it contains a 3 cross 3 matrix. So one way of retrieving the data from a field is to use the cell environment, and the other one that if you know the individual elements, so then you can define the variables, and then you can assign it to different variables, and that will hold the data corresponding to this matrix, corresponding to this field. One final note with regards to this assignment here is that when we are having three variables, so only the first three rows of this S1.a field will be retrieved. So let's say we have a fourth field, and that fourth field is equal equals to 10, let's say. And then we look at the contents of S1A. So the fourth field only contains 10, while the first field is what the first field, the first row of this field A contains 1, 2, 3, and then the second row contains hello, and the third one this is fourth. So if we mention only 3 variables, so now we will be having data retrieved corresponding to the first 3 rows of this field. Right? So the fourth row will be ignored. So I will strongly recommend you to use this cell structure in order to retrieve the data, because it does not has that kind of application, and all of the data corresponding to a particular field will be retrieved. Right? So all data has now been retrieved within this particular cell. So you can do other customizations and other tricks. Hope you are enjoying the course. See you in the next segment. Hello students, welcome again to the new segment. In this segment we will be looking at how to convert from cell data type to other data types. So the first example that we will be covering is to convert a cell data type to a table data type. So let's see how we can do that. So for this purpose I have created already a cell array C, which contains 4 by 4 cell array. So it contains numeric values and some character arrays, right? So multiple types of data. So now I want to convert this cell into a corresponding table. So what I need to do, I need to use a function called cell to table. And then when I pass to it this C variable, so please remember that when it is converted to a corresponding table, so the values will either be treated as numerics or they will be treated as cell arrays. Right? So when I convert it, so it will return either numeric values or they will convert the characters into cells. Right? So that's how it's going to work. So alternatively, if you want to give meaningful names to the variables using a single shot, so there is another variant of the same function. That is, we need to mention alongside this, we need to mention variable names, and then we need to give the values to the variables that we wish to have. So we have 4 variables in this case, and then we can say the first one is age, the second one is favorite food, and then for the third one we can say the calories, and then for the fourth one you may say likes, dislikes, and so many others, right? So that's how it's going to work. And we also need quotes over here, so pretty much done. So let's run it. Right? So now we, in a single shot, we have the table columns being set, and also the corresponding cell is also being converted into the corresponding table. So that was how to convert a cell into a table. So please also note that there is no built-in function for converting a cell directly to a timetable. However, the way around is to first convert a cell into a table, and then convert the table from the table into a timetable, right? So that's a two-step process: cell to table using the function cell to table, and then from table to timetable. Right? So you need to use the function table to timetable in order to convert it from table to timetable. Right? So that's how you can proceed. So let's see how we can convert a cell data type to an ordinary matrix. In order to do that, we need to use a function cell to mat, right? But this function requires that the entries must be in of one data type, right? So all of them should either be numerics or any other data type that you're using, but they must follow all the cells within the cell should have the same data type. Right, so let's do a quick example. So we define a cell, let's say containing random values, and the second item, the second element of that cell also contains some random values. So let's say red 4, so now it has a 2x1 cell array. The first element contains 3 by 3 matrix, and the second element contains 4 by 4. So So now in this case, the cell to mate function, it will give you an error message, right? That's because we cannot concatenate them together because their sizes are not consistent. Right? So it will give you an error message. So the second restriction here with using this cell to mat function is that the sizes of these individual cells should be such that it can be concatenated together. So if we do it now, we can easily concatenate them together, right? So this was a 3 cross 3 matrix. So the first 3 entries becomes the first 3 rows of our corresponding matrix, and then the second cell, it becomes the second element, the next 3 rows of our corresponding matrix. So there are 2 restrictions with this particular function if you want to convert a cell to a matrix. The first one is that it should contain the same data type elements, and the second restriction is that they must be able to, their sizes must be such that we are able to concatenate them together within the matrix. So let's see some more functions. So now let us look at how we can convert a cell to a corresponding structure. So for that purpose, we need to look at this example. So in this example, we need to create a cell which leads to this information. That is, in the rows we have the development variable, and then in the columns it represents 5 years, 10 years, or 15 years of experience. And then we have a look at the sales, right? And then the management information, and then the quality, and so on. So in order to do that, we can create these 5 cell arrays, and then we can concatenate them. So let's quickly do this example and see how cell to structure works. So let's see that. So now we have a 5 cross 3 cell array. This represents the variables such as the development, documentation, sales, and so on. And this represents the experience, 5 years, 10 years, and 3 years, right? So it is a corresponding cell array, which is 5 cross 3 in this case. So if we want to look at it more closely, so our cell array is something like this, where on the rows we have development, sales, management, quality, and documentation, and then on the columns we have the years of experience, right? So this is a 5 cross 3 cell array. But remember, we do not have this information stored with the cells, right? And also this information is not being stored, so we need to say it explicitly there when we are converting the cell to a structure. So let's see how we can do that. So the first thing we want to do is we want to have some meaningful names for the rows, and we want to store them explicitly. So we created another cell array here, and now it will contain the information for the row headings. So the first row corresponds to development, the second to sales, and so on. So now when we try so now let us look at how we can convert this cell array into the corresponding structure. So for that purpose, we need to use the function cell to struct. So let's say department equals to cell to struct, and then we need to mention which cell array we want to convert to a corresponding structure, and then we need to say what should be the individual fields of that structure. So that information is contained in this cell, right? So it contains the name of the fields, and then we need to mention the dimensions. This is very important, and we need to have a very clear vision about it. So let's see what exactly this means. This means the meaning of this is that the rows are going to be our fields in this case. Right? So, and if we mention 2, then it will mean that the columns are going to be the fields of our corresponding structure. Right? So let's say let's see how it works for the rows. So when you press enter, it will create a 3 cross 1 structure. Why 3 cross 1? Because we have three instances of that, and we have 5 fields for each and every instance. So for instance, if we look at department 1, so it will contain the information regarding the first instance of that structure. And similarly, department 2 will contain the second instance, and department 3 will contain the third instance. So this department 2 corresponds to 10 years, and this corresponds to the 15 years. Right? So if you want to look at it visually, then that's the corresponding interpretation. Right? So we want to convert it corresponding to dimension 1. So based on dimension 1, our rows are going to be our individual fields, right? So these were the headings of the rows: development, sales, management, quality, and documentation. So these are going to be our fields, and then corresponding to these fields, this is our first structure data. This is our second instance of the structure, and this is the third instance of that structure. So V1 is the first instance, and it contains the corresponding information, that is lead, weed, and hill. Similarly, this is the second the second field of the first instance, that is OE and burns, and so on. Similarly, if we keep the dimension as 2, so it will then convert the corresponding structure with the fields that are represented by these columns. Right? So, and then this is going to be the instance 1 of the structure, second instance, third, fourth, and fifth, and so on. Right? So that's how it's going to work. So the dimension means by which dimension you want to keep the fields of the structure. So that's how you can convert a cell into a structure. Finally, please also note that there is no direct way for converting a cell into a map container data type, but again there is a way around, and the way around is to make sure that the cell has the same number of key value pairs, and then you can convert them using the map containers.map data type and pass to it relevant arguments. So that's it for now. See you in the next segment. Hello students, welcome again to the new segment. In this segment, we will be looking at how to convert from other data types to a table data type. So previously we have covered these functions cell to table, right? So we do not need to cover it again. We have already seen how to convert a cell data type to a table data type. Similarly, we have also covered how to convert a timetable data type to a table data type when we were covering the cells, right? So we don't need to cover that as well. So the only thing that is left behind is how to convert a structure, right? So struct to table. So how we can convert a structure data type to a table data type, right? So that's left, and we need to make use of this function that is struct to table. So let's see how we can do that. For that purpose, we need to create a structure first. So I have already created a structure, and this structure is a 1x2 structure array containing 3 fields: name, age, and the corresponding grade. So if we want to look, the first instance of that structure contains NOMA 3 and A plus grade, and the second instance of that structure contains ASA 28 and A. So when we are trying to use the function that is struct to table, we need to pass it the corresponding structure, and when we press enter, so please note that the structure fields, right, the name, age, and the grade, they are going to be changed to the variable names, right, and the structure instances, they are going to be part of our rows for the corresponding table. So that's how it's going to be converted. So you may have noticed that we do not have any last names over here. So you may choose any variable as your row name. So in this case, this makes more sense. So we can always do that, and we can use the properties of the table. So let's first assign it to some variable, say t equals to the structure, and then we can use the tree dot properties dot row names, and we can set it to t dot name. Right? So it means the name variable, it is going to be now our names, right? And similarly we can take rid of this variable by saying t dot name equals to empty, right? So now we have the corresponding row names. Alternatively, we may specify some additional arguments while we are using this function, struct table, such as I want the row names to be mentioned, right? So I can use this syntax, and this is what it. So you can say home1, or you can say student1, and then you can say student2. So in this case, now we have the row names automatically set for the two students, right? So that's how we can convert a structure to a table. So the general syntax is to pass it either the structure, in that case it will not have any row names, but if you want to have a meaningful row name, so then either you can specify it like this. So this is the syntax, the general syntax is name and then the corresponding value. So here you can set different properties, and you can always consult the documentation to see what other properties you can set. Okay, for the map containers, you may not be able to directly convert it into a table, so you may either convert it to a cell or some structure and then convert it to a table. Right, so that's the way around for converting our map container to corresponding table. So that's it for now. See you in the next segment. Hello students, welcome again to the new segment of the course. In this segment we will be looking at both the aspects, that is from converting other data types to a table data type, and then from table data type to other data types as well. But first we are looking at how to convert from other data types to table data type, right? And later on we will be looking at the other way around. So previously we have covered this function cell to table, right? So we do not need to cover it again. We have already seen how to convert a cell data type to a table data type. Similarly, we have also covered how to convert a timetable data type to a table data type when we were covering the cells, right? So we don't need to cover that as well. So the only thing that is left behind is how to convert structure. So struct to table. So how we can convert a structured data type to a table data type. Right? So that's left, and we need to make use of this function that is struct to table. So let's see how we can do that. For that purpose, we need to create a structure first. So I have already created a structure, and this structure is one by two structure array containing three fields, name, age, and the corresponding grade. So if you want to look, the first instance of that structure contains home1, 3, and 8 plus grade, and the second instance of that structure contains housing, and age. So when we are trying to use the function that is the struct to table, we need to pass it the corresponding structure, and when we press enter, so please note that the structure fields, right, the name, age, and grade, they are going to be changed to the variable names, right? And the structure instances, they are going to be part of our rows for the corresponding table. So that's how it's going to be converted. So you may have noticed that we do not have any last names over here. So you may choose any variable as your row name. So in this case, this makes more sense. So we can always do that. And we can use the properties of the table. So let's first assign it to some variable, say t equals to the structure, and then we can use the t dot properties dot row names, and we can set it to t dot name. So it means the name variable, it is going to be now our names, right? And similarly, we can take rid of this variable by saying t dot name equals to empty, right? So now we have the corresponding row names. Alternatively, we may specify some additional arguments while we are using this function, struct table, such as I want the row names to be mentioned, right? So I can use this syntax, and this is valid. So you can say one, or you can say student one, and then you can say student two. So in this case, now we have the row names automatically set for the new students. And so that's how we can convert a structure to a table. So the general syntax is to pass it either the structure, in that case it will not have any row names, but if you want to have a row meaningful row names, so then either you can specify it like this. So this is the syntax, the general syntax is name and then the corresponding value. So here you can set different properties, and you can always consult the application to see what other properties you can set. Okay, for the map containers, you may not be able to directly convert it into a table. So you may either convert it to a cell or some structure and then convert it to a table. Right? So that's the way around for converting our map container to the corresponding table. So that's it for now. See you in the next segment. So now let us look at how we can convert from table to other data types. So you may have noticed that we have already covered the table to cell, right? And we have already covered the table to time table. So we don't need to cover that again. The only function that we need to cover here is from table to struct. So for that purpose, the method providing this function, that is table to struct. So let's see how it's going to work. So if you have just followed me along, so we have created this table just recently, right? So let's see how we can convert it into the corresponding structure. So basically we need to use table to structure and then pass to it this table key and store the result in a meaningful variable. So table to structure. So we need to use the struct, not the full name structure. So it will return the corresponding structure. So remember, in this case, the variable names of the table are going to be our fields, and by default, it is not going to store the row names. Right? So hope you're enjoying the course. See you in the next few segments. Hello students, welcome again to the segment. In this segment, we're looking at how to convert from different data types to a cell data type. So the first function that you may be interested in is the cell str function. So if you pass to it some string or character, it will convert it to the corresponding cell. Let's say we have c equals to, so let's consider it as a character array. So remember that when we are creating the character array, all the elements should contain the same number of characters. So for instance, I can say and then the second element here is the pad, and then the third element is the, let's say, march. So when we create this, also contain 3 elements, and all of them are considered as character. So if we look at the type of C, we can say it's a 3 by 3 character array. When we do the cell function now, the cell str function, cell str function. So when we pass to it this C, so it will return a 3 by 1 cell array, right? So each individual row now being converted into the corresponding cell. Alternatively, if we pass to it string, so let's say we create s equals to a string array, so say string, and then for the string we say hello, that's the first string, and then we have another string, and we declare it, let's say, world, and then we have another string, we call it how are you, so these are 3 strings. And we note that there is no restriction for the size of the string that you want to make an array of. So you can press enter, and now this S contains the 2 strings, 1, 2, and 3. So please also note that starting from 2017, the new version of Matlab also allows the syntax. So you can say, instead of using the function string, you can use double quotes and it will work, right? But here in this version, which is 2016 with me, it is not work. So that was a little note. Okay, so when we try to use the celestial function, it will convert it into the corresponding cells. So now our C will contain cells, and it's really a cellular array across three sides. So we can access the individual elements. So the first one is hello, the second one is world, and the third element is the string, which is called how are you. Now let us look at how we can convert a table to a cell. So we have already created a table for that purpose, which is this table, and we want to convert it to the corresponding cell. So we need basically to use the table to cell function and pass to it the corresponding table. We want now contains the corresponding cell, so it will convert it into a cell array. So remember, the size of the cell array is going to be the same at the same as data of the table. With number of rows, it will contain 5 rows and 3 columns, so it will also contain 5 rows array of cells. Please note that the row names and the column names are not going to be stored in this case. So if you want to store the column names as well, so we can name that with below, and we can say t dot properties dot variable names. So that will become the three variable names will become the first row of our list cell now, and then we are going to P1, with P1 contains this one table. So now when we press enter, we have the table names as the column names as well, then we compare it to this particular cell array. So if you want to also append the names, so you can also access it by saying dot properties dot row names, right? And it will return the row names, and then you can manipulate it to the cell that you have already defined, right? So you can always do that as well. Next, let us look at how we can convert a timetable to a cell array. So remember, there is no direct function for that, and there is actually a two-step process. First, you convert a timetable to a table, and then a table to a cell, right? So we will be looking at how to convert a timetable to a table, right? So for that, the Matlab provided with a function called timetable to table. So let's see how that works. So for that purpose, I have already created a timetable, which is TT, and that is the corresponding timetable. So the first entry, in each entry, we need to have a time, a row time as well. So that's a timetable basically. Okay. So now let's use the function timetable to table, and it will convert the corresponding table to a timetable. So now let's say t equals to this. So, but you remember that these row times are also being transferred when we converting the timetable to a table. So, if you want to take rid of this row, this column which represents the time, so there is another variant of this function which is like this. You explicitly need to mention that we do not need to convert the row times. And then you set it to false, which means we do not want this. We need to say times, right? So when you press enter, so it will return the same timetable but without this additional row, right? So that's how you can do that. And then we can again use the table to cell function in order to convert it into a corresponding cell as we did previously. So we can say T1 equals to table to cell, and then pass to the corresponding T, let's say 62 now in this case, so it will return the corresponding cell array. And again, you can always work around how you can actually store this column as well. So you just need to concatenate the result, that is T2 equals to the concatenation of the T dot properties dot column names or variable names, and then we just append it with the current cell, which is T2, and when you press enter, so now you have the corresponding column name as well. So now let us look at how we can convert a structure into a cell. So I have already created a structure which is a 1 cross 2 structures, which means it has 2 instances and it has 3 fields: category, item, and name. So we need to use the function struct to cell and then pass the corresponding structure to it, and then we will store the result in some variable, say C. Right? So when we press enter, you may notice that it has created a 3 cross 1 cross 2 cell array. Right? What it essentially means that it has 3 fields. So the structure has 3 fields, so it becomes a row for us. And then it has also created it has dimensions 1 cross 2, so those 2 will become the dimensions of this cellular array as well, right? So in the first dimension, the third dimension, it contains the values for the first structure, right? So that means S1, which is 337.400 average, and then in the second one, the second element of that structure, which is branch 3 and SM, it is being stored in the second element here in this cellular array, right? So it's a little bit complex when you convert a structure to a cell, but essentially the syntax will be something like this, right? So it's in 3 dimensions. The first and the last represents these represents the fields, this represents the instances you have in your structure, and this represents the size of that structure. So that's how it works. So finally, if you want to convert a map container to a cell, so please note that there is no built-in function. However, there is a workaround for that. So I have created already a rainfall map, which contains 13 keys and value pairs. So if I want to convert it into a cell, so I will say, let's say something like this: C equals to, and I will say the keys first, and then I will pass the corresponding map structure, which is rainfall map in this case, and then I will say values, and then pass to it again the corresponding map container. So when I press enter, it will create the corresponding cell. So if I want to look at C, right, so you can say plot cell and then C, and it will plot it for us in order to look at what are the contents of C. The correct functions is cell plot, not plot cell. So when we press enter, it will give us the corresponding structure of the cell. It says that it is going to have 13 values over here, an array, right? And similarly, it is a cell array as well, containing 13 values. Right? So if you want to have a look at one element content, so it contains all of the names of the months, and then similarly, if we look at the second, so it contains the corresponding values. So that's how you can convert a map container to a cell. So the essential thing is that we do not have any built-in function. However, you can use the values and key functions in order to get the keys and values, and then assign it to a particular cell. So this lecture was about how to convert from different data types to a cell data type, and in the next lecture we will be looking at the complete reverse operation, that is how we can convert from cell to other data types. So stay tuned.